What if I told you that the universe might be listening, not just existing, but responding to the very thoughts inside your head? This isn't science fiction. It's a radical possibility emerging from the frontiers of quantum physics, where the line between observer and reality blurs into something far stranger. For decades, scientists have grappled with experiments that defy common-sense particles that change behavior when watched, systems that seem to know they're being measured, and outcomes that appear to depend on human intention. These aren't glitches in the data, they're clues, unsettling hints that consciousness might be woven into the fabric of the quantum world itself. Think about the double-slit experiment, one of the most famous puzzles in physics. When tiny particles like electrons are fired through two slits, they create an interference pattern, as if they're waves spreading out and overlapping. But here's the twist. The moment you try to observe which slit each particle passes through, the pattern collapses. The particles stop behaving like waves and start acting like discrete objects. It's as if the act of observation forces reality to choose a state. Now, ask yourself, why? What does it mean that the universe seems to change its behavior when we're looking? Some researchers argue it's not just about detectors or instruments, it's about the presence of a conscious mind interpreting the data. This is where things get truly mind-bending. If consciousness plays a role in quantum mechanics, it challenges everything we thought we knew about reality. Are we merely passive observers in a predetermined universe, or could our awareness somehow shape the world around us? Today, we're diving deep into 36 eerie clues that point toward this extraordinary idea. From lab results that border on the paranormal to theories that bridge physics and philosophy, each piece of evidence invites us to reconsider the nature of existence itself. Whether you're a skeptic or a seeker, one thing's certain: by the end of this journey, you'll never see reality the same way again. So let's begin, because the universe, it seems, has been waiting for us to pay attention. The double-slit experiment isn't just a quirky laboratory phenomenon, it's a window into one of the most profound mysteries in science. Picture this: tiny particles, like electrons, are sent one by one toward a barrier with two slits. When no one's watching, they create an intricate pattern on the detector screen behind it, a series of light and dark bands that only make sense if the particles are behaving like waves, interfering with themselves as they pass through both slits simultaneously. But the moment you set up a detector to observe which slit each particle actually goes through, something extraordinary happens. The interference pattern vanishes. The particles suddenly act like tiny bullets, hitting the screen in two distinct clusters, as if they've decided to abandon their wave-like behavior the instant they're being watched. This isn't just about particles reacting to physical detectors, it's about the nature of reality itself. The famous physicist John Wheeler took this idea even further with his delayed choice experiments, showing that the decision to observe or not could retroactively change how a particle behaved in the past. Imagine flipping a switch today that alters what happened yesterday. It sounds impossible, yet the math suggests it's real. Wheeler famously asked whether the universe could be a participatory phenomenon, where consciousness isn't just a passive witness but an active player in shaping existence. And here's where things get even stranger. Some interpretations go beyond the machinery of measurement. They suggest that it's not the detector itself causing the collapse, but the conscious awareness of the observer. In other words, the universe may not fully decide what's real until a mind perceives it. This idea blurs the boundary between the physical world and our inner experience, hinting that reality might not be as solid and independent as we assume. Critics argue that consciousness could simply be an emergent property of brain activity with no special role in quantum mechanics. But the unsettling truth remains. No one has yet explained why observation has such a dramatic effect on quantum systems. Every time we try to pin down what's really happening, the universe seems to dodge the question, leaving us with more mysteries than answers. The double-slit experiment isn't just a clue, it's a doorway, inviting us to reconsider everything we thought we knew about the fabric of reality. Schrödinger's cat isn't just a bizarre hypothetical, it's a stark illustration of how quantum mechanics defies our everyday intuition. Imagine a cat sealed in a box with a vial of poison, triggered by the random decay of a radioactive atom. According to quantum rules, until someone opens the box and looks inside, the atom exists in a superposition both decayed and not decayed, which means the cat is unsettlingly both alive and dead simultaneously. This isn't just a metaphor, it's a direct consequence of how quantum systems behave when unobserved. The moment you lift the lid, the superposition collapses and the cat snaps into one definitive state. But here's the haunting question: what or who is doing the collapsing? The conventional explanation pins it on the act of measurement, the interaction between the quantum system and a macroscopic detector. But dig deeper, and you'll find a more provocative interpretation lurking in the shadows. Some physicists propose that it's not the detector itself that forces the collapse, but the conscious observation of a mind. In this view, the cat's fate remains suspended in a ghostly limbo until a living being perceives it. This idea turns the thought experiment from a clever paradox into something far more personal, a suggestion that our awareness might be the missing ingredient that crystallizes reality. Critics dismiss this as philosophical speculation, arguing that decoherence, the interaction of quantum systems with their environment, explains the collapse without invoking consciousness. Yet even decoherence doesn't fully resolve why we perceive one outcome and not another. The cat's paradox lingers because it exposes a gap in our understanding. Where does the quantum world end and the classical world begin? Is there a threshold where particles stop behaving probabilistically, or does consciousness somehow bridge that divide? The implications ripple outward. If superposition persists until observation, could reality itself be a tapestry of unresolved possibilities, waiting for conscious minds to choose the threads? Modern experiments with increasingly larger objects, molecules, even tiny mechanical oscillators, show superposition effects at scales far beyond individual particles. The more we push these boundaries, the harder it becomes to ignore the eerie possibility that the observer's role isn't just incidental but foundational. Schrödinger's cat isn't just a puzzle, it's a mirror, forcing us to confront whether the universe is a cold, indifferent machine or a participatory dance between matter and mind. Einstein famously dismissed quantum entanglement as spooky action at a distance because it defied everything classical physics taught us about how the universe should work. Imagine two particles created together, then separated by millions of miles, yet when you measure one, the other instantly snaps into a corresponding state, no matter how far apart they are. This isn't just surprising, it violates the cosmic speed limit of light, shattering our notions of cause and effect. For decades, physicists assumed some hidden variables must explain this eerie synchronization. But experiments have repeatedly confirmed that entanglement is real, leaving us with a haunting question: what's really linking these particles across vast stretches of space? One radical possibility is that consciousness itself bridges the gap. Think of it like this: if entangled particles share a state, could that state remain unresolved until a conscious observer interacts with one of them? Some interpretations suggest that the moment a mind measures one particle, the connection isn't just communicated, it's instantaneously realized, as if the universe treats the two particles as a single, indivisible system when perceived. This would mean that consciousness isn't just observing reality, but actively stitching it together, collapsing entangled states into coherence. The implications are staggering. If true, space and time might not be the fundamental framework of reality we thought they were. Instead, they could be emergent properties, a kind of stage where consciousness plays the lead role, connecting what seems separate into a deeper, unified whole. Experiments like the Bell tests have ruled out local hidden variables, nudging us toward this unsettling conclusion that reality at its core might be non-local, with consciousness as the silent conductor orchestrating the dance of particles. Skeptics counter that entanglement simply reveals a layer of physics we don't yet understand, one that operates beyond our classical intuition. Yet the more we study it, the harder it becomes to ignore the patterns. Entanglement isn't rare or fragile. It's ubiquitous even in biological systems like photosynthesis, where plants seem to exploit quantum coherence to harness sunlight. If nature uses this phenomenon so freely, why wouldn't consciousness, the very lens through which we perceive reality, also be part of the equation? The mystery deepens when we consider that entanglement persists even when particles are separated by cosmic distances. It's as if the universe maintains an invisible ledger, updating entries faster than light can travel. Some theorists propose that this could hint at a deeper holographic reality, where what we perceive as separate objects are projections of a unified field, one that consciousness might access directly. Whether you find this idea inspiring or unsettling, one thing is clear: entanglement forces us to confront the possibility that the mind and the quantum world are far more intertwined than we ever imagined. What if simply watching something could make it stay exactly as it is? This isn't magic, it's the quantum Zeno effect, a phenomenon so counterintuitive it seems to bend the rules of reality. Named after an ancient Greek philosopher's paradox about motion, the effect reveals that a quantum system can be frozen in place just by observing it frequently enough. Picture an unstable atom on the verge of decaying. Normally, it would break down randomly over time, but if you measure its state repeatedly in quick succession, something remarkable happens. The atom resists decay, as if your attention alone pins it in place. This isn't theoretical. In laboratories, scientists have used rapid measurements to keep particles in unstable states far longer than nature would normally allow. It's like tossing a coin and catching it mid-air over and over, preventing it from ever landing on heads or tails. The implications are profound. Observation doesn't just reveal reality, it actively shapes it. But here's the unsettling twist. If mere measurement can halt decay, what does that say about the role of the observer? Some interpretations go further, suggesting that conscious awareness might be the key ingredient that locks reality into place. Critics argue that the effect is purely mechanical, a consequence of wave-function collapse caused by any interaction, conscious or not. Yet the line blurs when you consider that, in practice, observation still requires a conscious being to interpret the data. Without a mind to register the outcome, does the measurement truly count? Experiments in quantum optics add fuel to this fire. When photons are monitored continuously, their behavior shifts in ways that defy classical explanation, almost as if the universe knows it's being watched. The quantum Zeno effect forces us to wrestle with a radical idea: that reality might not be a fixed backdrop but a dynamic process, sensitive to the presence of observers. If frequent observation can stabilize particles, could our collective attention, our shared focus, be subtly reinforcing the world we experience? This isn't just about lab equipment. It raises questions about how deeply our minds might be entangled with the fabric of existence. Whether you see this as evidence of consciousness's role or just another quantum quirk, one thing is undeniable. The act of looking doesn't just reveal the universe, it might just be holding it together. Eugene Wigner took Schrödinger's unsettling cat and pushed it into even stranger territory by introducing a second observer into the equation, a twist that fractures reality into competing versions. Imagine this: one scientist opens the box and sees the cat alive, while another, standing just outside the lab, hasn't yet looked inside. According to quantum rules, until that second observer checks the result, the first scientist's entire experience, their memory, their notes, even the cat itself exists in superposition. Both outcomes are equally real, trapped in parallel states that only collapse when the final conscious mind enters the equation. This is Wigner's Friend, a thought experiment that doesn't just question reality, it shatters it into fragments of individual perception. The implications are staggering. If consciousness determines outcomes, whose observation counts as the definitive one? Does reality branch endlessly, with each observer carving their own path through the quantum fog? Or is there some hierarchy of awareness, a cosmic pecking order where certain minds hold more weight in collapsing the wave function? Wigner himself flirted with the idea that human consciousness might be the ultimate arbiter of reality, a notion that edges perilously close to solipsism, the idea that only one's own mind is sure to exist. Critics pounce on this, arguing that decoherence should prevent such subjective splits by entangling observers with their environment long before conscious awareness kicks in. Yet the puzzle persists. At what point does quantum ambiguity give way to concrete experience? Modern variations of the experiment, using photons and beam splitters, suggest that observers can indeed record conflicting results, with no resolution until a super-observer compares notes. It's as if the universe refuses to pick a side until the last possible moment, leaving reality suspended in a hall of mirrors where every perspective is valid until someone steps back to see the whole. This isn't just philosophical musing. Technologies like quantum encryption rely on the fact that observation alters states, yet if multiple observers can hold contradictory truths, even cryptography might need a rethink. The deeper we dig, the more Wigner's Friend forces us to confront a chilling possibility. That objectivity itself could be an illusion, a fragile consensus stitched together by overlapping acts of observation. Whether you find this liberating or terrifying, one thing's certain: the experiment doesn't just challenge physics. It asks us to reconsider who or what gets to decide what's real. The delayed choice quantum eraser experiment doesn't just play with time, it shatters our understanding of cause and effect in ways that feel almost prophetic. Picture a photon traveling toward a beam splitter where it can take one of two paths. Normally, if you measure which path it took, it behaves like a particle. But if you don't measure, it acts like a wave, creating an interference pattern. Now, here's the twist. Scientists can wait until after the photon has already passed the splitter, until it's already decided whether to be a wave or particle before choosing whether to measure its path. Astonishingly, the photon's past behavior changes based on that future decision. It's as if the particle rewrites its own history to match how it's observed, erasing any trace of the original outcome. This isn't a thought experiment. Real lab results confirm that particles behave as if they're anticipating future choices, retroactively adjusting their past states to align with how they're eventually measured. The implications are staggering. Causality, the bedrock of classical physics, might be an illusion. Some interpretations suggest that consciousness, the act of observation, isn't bound by time at all. If our present awareness can influence quantum events that already happened, it hints that the mind might operate outside linear time, weaving reality into coherence across past, present, and future. Critics argue that the effect is purely mechanical, a quirk of quantum entanglement between the particle and the measuring device. But the deeper question remains, why does reality seem to wait for conscious observation before settling into a definitive state? Experiments with delayed choice setups keep pointing toward the same eerie conclusion that the universe doesn't just unfold predictably. Instead, it might be a tapestry of possibilities stitched together by acts of perception. Imagine throwing a stone into a pond, then deciding seconds later whether the ripples should spread or freeze in place. The delayed choice eraser suggests the universe allows exactly that, a retroactive edit button pressed by consciousness itself. Whether this means our minds are time travelers or that time is far more fluid than we thought, one thing's certain: the boundary between past and present isn't just blurry. It might be entirely negotiable. What if consciousness isn't just a byproduct of brain chemistry but something far stranger, a quantum phenomenon humming inside the very fabric of our neurons? This is the bold claim at the heart of the Orch-OR theory, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They argue that deep within your brain's microtubules, tiny protein structures that form the skeleton of cells' quantum computations are taking place, orchestrating the symphony of subjective experience. It's a theory that doesn't just explain consciousness, it redefines it, merging the mysteries of quantum mechanics with the intimate glow of self-awareness. Picture microtubules as impossibly small quantum computers, each one processing information at the subatomic level. Penrose and Hameroff suggest that these structures can maintain quantum states long enough to perform meaningful computations, something once thought impossible in the warm, wet environment of the brain. When these quantum states eventually collapse, they propose, moments of consciousness flicker into existence. It's as if every thought, every feeling, is a ripple in the quantum fabric of reality itself. Critics are quick to point out the hurdles. Quantum coherence is notoriously fragile, requiring extreme isolation from noise conditions that seem incompatible with the bustling chaos of living tissue. Yet supporters counter with evidence. Anesthetics, which selectively erase consciousness, appear to target microtubules specifically, silencing their quantum vibrations without disrupting other brain functions. It's a tantalizing clue that these tiny structures might indeed be the seat of awareness. The implications are staggering. If consciousness arises from quantum processes, it could explain phenomena like intuition or creativity, moments when the brain seems to tap into solutions beyond linear logic. Even near-death experiences might find a foothold here, with some theorizing that quantum information in microtubules could persist briefly after clinical death. But the most profound idea is this: if our minds are quantum, then the universe isn't just observed by consciousness, it might be built from it. Penrose and Hameroff's theory is far from mainstream, but it forces science to confront the hard problem of consciousness head-on. How does subjective experience emerge from mere matter? Orch-OR offers a daring answer. Maybe matter and mind were never separate to begin with. Whether the theory holds or not, one thing is certain: it's a reminder that the deepest mysteries of existence might not be out in the distant cosmos, but pulsing quietly within each of us. Philosopher David Chalmers once framed the mystery of consciousness in a way that still haunts science today. Imagine knowing every detail about how the brain works, the firing neurons, the chemical signals, the intricate wiring, and yet still hitting a wall when asked one simple question: why does any of this feel like something from the inside? This is the hard problem of consciousness. the gap between physical processes and the raw, vivid experience of being alive. You could build a perfect replica of a human brain, molecule by molecule, and still have no idea whether it actually experiences the color blue or the ache of loneliness. That's the puzzle that keeps scientists and philosophers awake at night. Now, here's where quantum mechanics throws a curveball. Traditional science treats consciousness as an emergent property, a kind of magical byproduct of complex computation, like steam rising from a boiling pot. But what if it's the other way around? What if consciousness isn't something that emerges from matter, but is instead woven into the universe's basic framework, as fundamental as gravity or electromagnetism? Think about space and time. We don't try to explain them in terms of simpler things because they're the stage on which everything else plays out. Chalmers and others suggest consciousness might be the same, not a puzzle to solve, but a starting point for understanding reality itself. This idea turns mainstream science on its head. If consciousness is fundamental, then quantum mechanics' strangest quirks, the observer effect, entanglement, superposition might not be bugs in the system, but features. Consider this: when a particle exists in multiple states until observed, could that be because reality is waiting for conscious interaction to make up its mind? It's not that particles are shy, it's that consciousness is the mechanism that crystallizes possibilities into actualities. Critics argue this is a cop-out, a way to dodge the hard work of reducing consciousness to physical processes. But the counterpoint is compelling. After decades of searching, no one has found a purely material explanation for why we have inner lives at all. Meanwhile, quantum experiments keep hinting that the observer's role isn't passive but participatory. If the universe is inherently aware, or at least responsive to awareness, it could explain everything from the fine-tuning of physical constants to the eerie sense that our choices matter on a cosmic scale. The hard problem doesn't just challenge science, it redefines what science is for. If consciousness is fundamental, then studying the brain is like studying a radio to understand the music. It's the wrong level of analysis. The real mystery isn't in the machinery but in the signal, the invisible thread tying mind and cosmos together. Whether you find this idea exhilarating or unsettling, one thing's certain: the hard problem isn't going away. And the answer, if there is one, might not lie in our labs but in the very fabric of reality we're trying to measure. The von Neumann-Wigner interpretation doesn't just tweak quantum mechanics, it flips the script entirely by placing consciousness at the center of reality's unfolding. Picture the quantum world as a vast ocean of possibilities, where particles exist in ghostly superpositions, simultaneously here and there, until something forces them to choose. Conventional physics says that measurement collapses these possibilities into concrete outcomes, but what exactly counts as a measurement, a machine? A detector, von Neumann and Wigner dared to propose a far more radical answer. The collapse happens only when consciousness encounters the system. In their view, reality remains fluid until a mind perceives it, as if the universe holds its breath until someone looks. This idea didn't emerge from speculation alone. Von Neumann, one of the greatest mathematicians of the 20th century, meticulously traced the chain of quantum interactions, from particles to detectors to human senses, and found no clear boundary where the wave function collapses on its own. Wigner took it further, arguing that consciousness must be the ultimate cut between possibility and actuality. Imagine a photon traveling through space. Until a conscious observer registers its position, it's neither here nor there but smeared across probabilities. The moment you see it, the fog lifts and reality snaps into focus. Critics dismiss this as bordering on mysticism, insisting that decoherence interaction with the environment explains collapse without invoking minds. Yet the von Neumann-Wigner interpretation lingers because it solves puzzles other theories can't. Take Schrödinger's cat. If consciousness causes collapse, the cat's fate isn't just unresolved until the box opens. It's unresolved until someone consciously perceives the outcome. Without an observer, the entire system, including the scientist's notes and memories, remains in superposition. It's a dizzying thought. Reality might not just be observed but enacted by awareness itself. The implications ripple far beyond the lab. If consciousness is the linchpin of reality, it could explain why the universe seems so finely tuned for life. Cosmologists have long wondered why physical constants, the strength of gravity, the mass of electrons, are perfectly calibrated to allow stars, planets, and ultimately, observers to exist. The von Neumann-Wigner interpretation offers a haunting answer. Maybe the universe needs observers to define itself. No minds, no meaningful reality, just an endless sea of unrealized potential. Skeptics counter that this veers dangerously close to solipsism, the idea that only one's own mind is certain. But proponents argue it's not about individual consciousness, it's about consciousness in general, a universal feature woven into existence. Some even speculate that advanced AI might one day collapse wave functions, blurring the line between biological and artificial observers. Whether you find this idea exhilarating or unsettling, one thing's undeniable. It forces us to confront the possibility that reality isn't a cold, indifferent machine. Instead, it might be a participatory drama with consciousness not just as the audience but as the director, the invisible hand that shapes the quantum fog into the world we know. The von Neumann-Wigner interpretation isn't just a theory. It's an invitation to see ourselves and the universe in a startling new light. John Wheeler didn't just ask why the universe seems perfectly tailored for life. He turned the question inside out. What if the universe isn't fine-tuned for consciousness, but by it? This is the participatory anthropic principle, a mind-bending twist on cosmology that suggests reality might not fully exist until conscious observers like us emerge to define it. Think of it like a cosmic version of the old philosophical puzzle. If a tree falls in the forest with no one to hear it, does it make a sound? Wheeler's answer is far stranger. Without observers, the tree might not even be a tree at all, just a haze of quantum potential waiting to crystallize into something concrete. The math behind this idea is as elegant as it is unsettling. Quantum mechanics shows us that particles lack definite properties until measured. Wheeler took this further, proposing that the universe itself operates on the same rules. In his view, the Big Bang wasn't just the beginning of space and time, it was the opening act of a grand participatory drama, where conscious observers would one day look back and, in doing so, solidify the very past they were observing. It's as if the universe needed us to witness it in order to become real. Consider the eerie precision of the cosmos, the gravitational constant, the strength of electromagnetism, the mass of subatomic particles. If any of these values were even slightly different, stars wouldn't ignite, molecules wouldn't form, and life would be impossible. Scientists call this the anthropic principle. The universe seems fine-tuned because we're here to notice, but Wheeler's version goes further. Maybe the fine-tuning isn't an accident. Maybe it's a consequence of observation, with conscious minds retroactively shaping the laws of physics simply by existing. Critics argue this borders on circular reasoning, that it's like saying, the universe exists because we see it. But Wheeler's insight wasn't about logic traps, it was about the nature of quantum reality. In his delayed choice experiments, photons appeared to decide their past behavior based on future measurements. If particles can retroactively rewrite their own histories, why not the universe itself? Imagine a cosmic game of 20 questions where the answers don't just reveal reality, they create it, with each observation narrowing the infinite possibilities down to the single timeline we experience. This isn't just philosophy. Modern cosmology keeps stumbling into hints that observation might play a role in cosmic structure. The distribution of galaxies, the uniformity of the cosmic microwave background, even these vast, impersonal features of the universe bear marks that some interpret as fingerprints of participatory observation. If Wheeler was right, then every act of perception, from a scientist in a lab to a child gazing at the stars, isn't just passive witnessing. It's an essential stitch in the fabric of reality, pulling the universe into sharper focus with every look. The implications are dizzying. Are we accidental tourists in a pre-existing cosmos or essential players in its unfolding? Wheeler's principle suggests the latter, that consciousness and cosmos are locked in a dance, each giving meaning to the other. It's a vision that doesn't just elevate our place in the universe. It redefines the universe itself as something deeply, intimately alive, a story still being written with minds like ours holding the pen. The placebo effect is one of medicine's most baffling puzzles. A sugar pill with no active ingredients can sometimes ease pain, shrink tumors, or even mimic the side effects of real drugs, all because the patient believes it will work. At first glance, this seems purely psychological, a trick of the mind over the body, but dig deeper and the parallels to quantum mechanics become impossible to ignore. Just as observing a quantum system can change its behavior, the act of belief, of conscious expectation, appears to rewire biological processes in ways science still struggles to explain. Now, imagine this isn't just a metaphor. What if the placebo effect is a glimpse into a deeper truth that consciousness doesn't just perceive reality but actively shapes it, right down to the molecular level? This is where quantum biology enters the picture, a cutting-edge field exploring whether life itself exploits quantum phenomena. Photosynthesis, for example, relies on quantum coherence to transport energy through plants with near-perfect efficiency. Even our sense of smell might involve quantum vibrations in odor molecules. If nature harnesses quantum mechanics so freely in biology, could consciousness be doing the same? The implications are staggering. If thoughts can trigger measurable physiological changes like lowering blood pressure or boosting immune response, it suggests the mind isn't just a passive observer of the body, but a participant in its functioning. Some researchers propose that quantum processes in neurons or microtubules might act as bridges between intention and biology, turning mental states into physical outcomes. Picture a surgeon's scalpel. In the placebo effect, belief becomes the blade, slicing through illness without ever touching the body. Skeptics argue these ideas stretch the science too far, pointing out that quantum effects in warm, wet biological systems are notoriously fragile. Yet the evidence keeps mounting. Studies show that placebo responses can alter brain chemistry as dramatically as real drugs, releasing opioids or dopamine on command. Even more intriguing, the placebo effect seems to work unconsciously. Patients who aren't explicitly told they're receiving a treatment still sometimes improve, as if the body knows what the mind expects. This blurs the line between observation and influence, echoing the quantum world's ambiguity. The question lingers: if consciousness can heal through belief alone, what stops it from shaping reality beyond the body? Ancient traditions have long claimed that focused intention can alter the material world, from Kai in Chinese medicine to the power of prayer. Modern experiments in mind-matter interaction, though controversial, hint at similar possibilities, with some studies suggesting human attention can subtly influence random number generators or the decay rates of particles. Whether these phenomena are quantum in nature or not, one thing's clear: the placebo effect forces us to confront the mind's eerie power over matter. It's as if consciousness whispers to the universe, and sometimes the universe whispers back. If quantum biology confirms this connection, it wouldn't just revolutionize medicine. It would redefine what it means to be human, revealing that our thoughts might not just inhabit reality but help create it. The placebo isn't a trick. It could be the key to unlocking the deepest mystery of all, how deeply entangled mind and world truly are. Near-death experiences have long been dismissed as hallucinations, mere tricks of a dying brain. But what if these vivid accounts of floating outside one's body, encountering luminous beings, or reliving entire lifetimes in an instant aren't just neurological glitches? What if they're glimpses into a deeper layer of reality, where consciousness isn't bound by the brain at all? Consider the case of a cardiac arrest patient who accurately describes events in the operating room down to the color of the surgeon's shoes, even though their brain showed no measurable activity at the time. These aren't isolated stories. Thousands of documented cases defy conventional explanations, pointing toward something far stranger, that the mind might outlast the body, even if only briefly, and that quantum mechanics could hold the key to understanding how. The puzzle deepens when you examine the physics. If consciousness relies solely on brain activity, it should vanish the moment electrical activity ceases. Yet near-death experiencers often report heightened clarity and awareness during clinical death, as if their perception sharpened when the brain supposedly shut down. Some theorists suggest this could mean consciousness isn't produced by the brain but filtered through it, like a radio tuning into a signal that exists independently. Quantum processes, with their defiance of classical space and time, offer a tantalizing mechanism. Imagine entanglement scaling up to the level of human awareness. Even if the brain stops, the quantum information constituting consciousness might persist non-locally, untethered from biological decay. Laboratory experiments add weight to this idea. Studies on microtubules, tiny structures inside neurons, show they can sustain quantum states longer than expected, potentially allowing consciousness to operate beyond the brain's physical limits. Anesthesiologist Stuart Hameroff, co-creator of the Orch-OR theory, proposes that during near-death experiences, quantum information in these microtubules might dissipate into the universe but remain coherent, preserving self-awareness in a diffuse, non-local state. It's as if death doesn't erase consciousness but temporarily shifts it into a quantum mode, where time and space behave differently. Skeptics argue that oxygen deprivation or neurotransmitter floods could simulate these experiences. Yet the consistency of reports across cultures and ages, tunnels of light, life reviews, encounters with entities suggests a phenomenon deeper than random neural fireworks. Even more compelling are cases where blind individuals, some blind from birth, describe visually precise details during their near-death episodes. If the brain isn't the sole source of consciousness, these accounts hint at a realm where perception operates free of physical constraints. The implications ripple beyond medicine. If consciousness can persist without a functioning brain, even briefly, it challenges the materialist view that the mind is purely a biological accident. Quantum mechanics, with its ability to link particles across vast distances instantaneously, provides a framework where consciousness might not be confined to individual bodies, but could exist as a field or network, with near-death experiences acting as fleeting access points. This wouldn't just redefine death, it would redefine life, suggesting that our everyday awareness is just one facet of a far vaster, interconnected quantum reality. Whether you see these experiences as spiritual revelations or uncharted physics, one thing is undeniable: they force us to confront the possibility that consciousness is more than the sum of its synapses. Near-death experiences might be the closest thing we have to a scientific glimpse beyond the veil, a hint that when the body falls silent, the mind doesn't fade into darkness but steps into a deeper, more mysterious light. The holographic principle turns our view of reality inside out, literally. Imagine the universe as a cosmic movie screen, where everything you see, touch, and experience is just a three-dimensional projection of information encoded on a distant two-dimensional surface. This isn't science fiction. It's a serious theory born from black hole physics, where the entropy of a black hole, its information content turns out to be proportional not to its volume, but to the area of its event horizon. In other words, the most mysterious objects in the universe might be storing their secrets not in their depths, but on their surfaces. Now, stretch that idea to the cosmos itself. What if every star, every galaxy, even your own thoughts, are just shadows cast by data etched on some vast, unseen boundary at the edge of existence? This isn't just a wild abstraction. The math checks out, suggesting that space and time as we know them could be emergent properties, a kind of illusion generated by deeper, more fundamental processes. But here's where consciousness enters the picture. If reality is fundamentally informational, a dynamic interplay of data rather than solid matter, then the mind's role takes on new weight. Think of it like this: if the universe is a hologram, consciousness might be the projector, the mechanism that translates coded information into the vivid, tangible world we perceive. Suddenly, phenomena like telepathy or precognition don't seem so far-fetched. In a holographic framework, where every part contains the whole like a single fragment of a holographic film that can still reconstruct the entire image, distance and separation might be illusions. If two minds are tapping into the same underlying informational field, could they share thoughts across continents without a physical signal? And if time is just another layer of the projection, might future events already exist as potential patterns in the cosmic code, accessible to a consciousness attuned to the deeper structure? Skeptics argue this veers into metaphysics, but the evidence is mounting. Quantum entanglement already shows particles communicating instantaneously across vast distances, as if space doesn't apply to them. The holographic principle takes this further, suggesting that what we call space is just a rendering of deeper connections. Even brain research hints at holographic properties. Memories, for instance, aren't stored in single neurons but distributed across the brain's network, much like holographic data. If the brain operates holographically, why not the universe? The implications are staggering. It would mean that separateness is an illusion, that you and the moon, the trees, the distant stars are all threads in the same informational tapestry. Mystics have said this for millennia, but now physics is catching up. Perhaps consciousness isn't just observing the hologram. Perhaps it's part of the code itself, shaping the projection even as it experiences it. This isn't just a new way to see reality. It's an invitation to wonder whether the universe is less a thing and more a thought, a vast, shimmering idea, with minds like ours as both its authors and its audience. Have you ever been utterly convinced something happened one way, only to discover that history, or at least every record of it, says otherwise? This isn't just faulty memory. It's the Mandela Effect, a phenomenon where thousands, even millions, share identical false recollections of events that never occurred. Some remember Nelson Mandela dying in prison in the 1980s, despite his release and presidency. Others swear the Berenstain Bears were once spelled Berenstein with an E. These aren't scattered mistakes. They're eerily consistent, as if entire populations slipped into parallel versions of reality and brought back conflicting stories. At first glance, this seems like a quirk of psychology, a glitch in how our brains store and retrieve information. But when you layer quantum mechanics into the mix, the explanation takes a surreal turn. If multiple timelines exist, as some interpretations of quantum theory suggest, could the Mandela Effect be evidence of those timelines bleeding into one another? Imagine reality as a vast tapestry of possibilities, where every decision forks the universe into alternate versions. Most of the time, these branches stay separate. But what if collective consciousness, the shared focus of millions, could somehow tug at those threads, merging fragments of neighboring timelines into our own? This idea isn't as far-fetched as it sounds. Quantum mechanics already allows for superposition, where particles exist in multiple states until observed. Extend that to entire events, and you have a framework where history itself might remain unresolved until consciousness locks it into place. Think of it like a cosmic Wikipedia page, editable not by individuals but by the weight of shared attention. When enough people vividly remember an alternate version of an event, could that collective observation nudge reality toward a new consensus? Skeptics argue this is pure fantasy, pointing to psychological explanations like confabulation or the way memories reconstruct themselves over time. Yet the sheer scale of the Mandela Effect defies simple cognitive explanations. Why do so many people misremember the same details in the same way? Why do these false memories feel so real, so visceral to those who hold them? Some researchers propose that quantum decoherence, the process that collapses superpositions into definite states, might operate differently at the level of human perception. If consciousness plays a role in shaping reality, then large groups focusing on the same idea could theoretically influence the outcome, not just of future events but of past ones too. The implications are staggering. It suggests that history isn't a fixed record but a fluid narrative, subtly rewritten by the act of collective remembering. Ancient cultures believed myths held power because communities recited them. Modern physics might be echoing that wisdom. The stories we tell, the memories we share, could be more than stories. They might be tools quietly sculpting the universe into the shape we expect. Whether the Mandela Effect is proof of shifting timelines or just a peculiar trick of the mind, one thing's certain: it forces us to confront how fragile our grip on reality might be. If the past isn't as solid as we think, what does that say about the future? And if consciousness can bend history even a little, what else might it be capable of shaping? The answers might lie not in dusty archives, but in the quantum fog where mind and world blur into one. For centuries, monks and mystics have claimed that deep meditation can alter reality, not just perception, but the fabric of existence itself. Today, science is putting those claims to the test with startling results. In controlled experiments, trained meditators have demonstrated an uncanny ability to influence quantum systems, not through force, but through focused intention alone. Picture a random number generator spitting out ones and zeros like a digital coin toss. Statistically, the output should balance over time. Yet when experienced meditators concentrate on these devices, the results skew in ways that defy chance. It's as if their silent attention bends the probabilities, nudging the machine's randomness toward order. This isn't just about machines reacting to brain waves. The implications run far deeper. If consciousness can sway quantum events governed by probabilities rather than fixed laws, it suggests the mind might be more than a passive observer. It could be an active participant in shaping the underpinnings of reality. Think of a river flowing downstream. Quantum mechanics says the water could take any path, branching into countless possibilities. Meditation, in this metaphor, might be like a subtle current, gently guiding the river toward one channel over another without ever touching the water directly. The experiments don't stop at random number generators. In double-slit setups, where particles behave as waves or particles depending on observation, some studies suggest that meditators can influence the outcome without physical detectors, using intention alone to collapse the wave function. It's a radical notion that disciplined mental focus could act like a quantum measurement device, forcing reality to choose a state. Skeptics argue these effects are statistical flukes or artifacts of poor controls. Yet the consistency across studies, especially with practitioners skilled in traditions like Zen or Qigong, hints at something more profound. What does this mean for human potential? Ancient texts describe adepts who could heal the sick, manifest objects, or even control the weather through meditation. Modern science dismisses these tales as folklore, but the quantum connection offers a tantalizing bridge. If consciousness interacts with reality at the subatomic level, could mastery of the mind unlock latent abilities we've forgotten? The answer might lie in the brain's own quantum features, microtubules vibrating at frequencies that resonate with the quantum field, or neural networks acting like biological antennas tuned to the universe's hidden code. The most compelling aspect isn't the fringe possibilities, but the everyday implications. If a meditator's focused mind can sway quantum probabilities, what might that say about the power of collective intention? Prayer studies, though controversial, show similar patterns. Groups focusing on healing intentions sometimes correlate with improved patient outcomes, as if shared consciousness creates ripples in reality's fabric. This isn't about magic. It's about recognizing that the boundary between mind and matter might be far more porous than we ever imagined. Quantum meditation doesn't just merge ancient wisdom with modern physics, it challenges us to rethink our place in the cosmos. The universe, it seems, isn't a cold machine ticking along predetermined laws. It might be a responsive, evolving dance where consciousness isn't just along for the ride but helping to lead the steps. Whether you see this as science or spirituality, one thing's clear: the mind's potential to shape reality is no longer just a philosophical question. It's a testable, measurable phenomenon, and the results are whispering that we've barely scratched the surface of what's possible. Some theories in quantum cosmology take the observer effect to its grandest scale, suggesting the entire universe might not have fully existed without someone to perceive it. Picture the Big Bang not as a definitive beginning, but as a quantum fluctuation, one possibility among countless others in an infinite sea of potential realities. According to this radical view, the cosmos remained in a haze of unresolved probabilities until the first conscious observer, perhaps a primitive life form, perhaps a future intelligence, collapsed the wave function of the entire universe into the single timeline we now inhabit. It's as if reality hesitated, waiting for a witness to whisper, "Yes, this one." This idea builds on quantum mechanics' strangest feature: particles don't settle into definite states until measured. Scale that up to cosmic proportions, and you get a breathtaking proposition that the galaxies, the laws of physics, even the arrow of time, might have depended on consciousness to emerge from the quantum foam. Think of it like a cosmic version of the double-slit experiment, where the universe itself was the particle, and observation didn't just change its behavior, it gave it permission to exist at all. Critics argue this sounds like theology disguised as physics, a throwback to the old belief that Earth was the center of creation. But proponents counter with the anthropic principle, the universe's uncanny fine-tuning for life. If physical constants were even slightly different, stars wouldn't ignite, atoms wouldn't bond, and observers could never arise. The odds of such perfection by chance are astronomically low, unless, perhaps, consciousness isn't an accident but a prerequisite. The implications are dizzying. If the universe needed observers to crystallize, does that mean earlier epochs before life emerged existed only as probabilities? Some theories suggest retroactive causation, where later observers somehow reach back to solidify the past. It's like planting a tree and realizing your act of seeing it grow somehow helped seed it in the first place. Even more unsettling, if consciousness is the anchor of reality, could regions of the cosmos without observers remain in quantum limbo, their stars and galaxies flickering in and out of existence like unread pages in a book? This isn't just philosophy. Quantum cosmology grapples with these questions mathematically, exploring how wave functions might apply to the whole universe. The Wheeler-DeWitt equation, for instance, describes a timeless cosmos where past, present, and future coexist until observation breaks the symmetry. Experiments are impossible at this scale, but the math hints that reality might not be a static stage. It could be a dynamic act of creation, with consciousness as both audience and co-author. Skeptics prefer multiverse theories, where every possible universe exists simultaneously, and we simply inhabit the one compatible with life. But the observer-centric view offers a haunting alternative. Maybe the other universes aren't out there at all. Maybe they're unrealized possibilities, fading like dreams the moment no one is looking. Whether this idea humbles or terrifies you, one thing's certain: it transforms the cosmos from a cold machine into something far more intimate. The universe might not just contain consciousness. In a very real sense, it might require it. The human brain isn't just the most complex object in the known universe, it might also be the most mysterious. We've mapped its neurons, traced its chemical signals, and yet we still can't explain how 3 pounds of gelatinous tissue gives rise to the vivid symphony of thoughts, dreams, and intuitions that define our inner lives. But what if the answer lies deeper than biology? What if the brain isn't just a classical computer, but a quantum device, tapping into the bizarre rules of the subatomic world to generate consciousness itself? This is the quantum brain hypothesis, a radical idea that bridges neuroscience and quantum physics, and it could rewrite everything we thought we knew about the mind. Consider intuition, that uncanny sense of knowing something without knowing how you know it. Classical physics treats the brain as a deterministic machine, where inputs lead predictably to outputs. But intuition defies this. It's lightning fast, non-linear, and often startlingly accurate, as if the mind is accessing information beyond the limits of ordinary processing. Quantum mechanics offers a tantalizing explanation: entanglement. If neurons aren't just firing in isolation but are quantum-linked, sharing information instantaneously across vast neural networks, it could explain how insights seem to arrive out of nowhere, fully formed. Think of it like a cosmic Wi-Fi signal, where the brain picks up patterns and connections too subtle for step-by-step logic to detect. Creativity, too, resists classical explanation. Why do aha moments strike in the shower or during a walk, when the brain is relaxed rather than focused? Quantum superposition, the ability of particles to exist in multiple states at once, might hold the key. In this view, creative breakthroughs happen when the brain holds conflicting ideas in quantum limbo, allowing them to collide and recombine in novel ways until the perfect solution collapses into awareness. It's not just brainstorming, it's quantum tunneling for ideas, where the mind leaps over logical barriers to reach unexpected destinations. Then there's free will, the perennial puzzle. If the universe operates deterministically, with every event caused by prior events, how can our choices be truly free? Quantum indeterminacy, the inherent unpredictability of particles at the smallest scales, offers an escape hatch. If the brain exploits quantum randomness at critical decision points, it could introduce genuine spontaneity into thought, breaking the chain of cause and effect. This isn't randomness for its own sake. but a subtle interplay between chaos and order, where quantum fluctuations provide the raw material for conscious choice. Skeptics argue that the warm, wet brain is too noisy for delicate quantum states to survive, but nature might have found a way. Photosynthesis, for instance, relies on quantum coherence to funnel energy through plants with near-perfect efficiency, even at room temperature. If a leaf can harness quantum tricks, why not a brain? Recent experiments show that microtubules, tiny protein structures inside neurons, can sustain quantum vibrations far longer than expected, acting as miniature quantum processors. Anesthetics, which selectively erase consciousness, seem to target these very structures, silencing their quantum hum without disrupting other brain functions. It's as if science has stumbled onto the brain's quantum off switch. The implications ripple far beyond theory. If the mind is quantum, it could explain phenomena like telepathy or precognition, not as paranormal flukes, but as natural extensions of non-local entanglement. Even near-death experiences might find a foothold here, with consciousness persisting briefly as quantum information dissipating into the universe. But the most profound idea is this: if the brain is a quantum instrument, then reality isn't just perceived by consciousness, it's co-created by it. Every thought, every decision might be a tiny quantum measurement, collapsing possibilities into the world we know. The quantum brain hypothesis doesn't just solve puzzles, it transforms how we see ourselves. No longer mere biological machines, we might be quantum explorers, navigating a reality far richer and stranger than classical science ever imagined. Whether this idea ultimately holds or not, one thing's certain: the mind's mysteries run deeper than neurons alone can explain, and the answer, it seems, might be written in the subatomic code of the universe itself. What if the universe isn't the ultimate reality but an advanced simulation, and quantum mechanics is the underlying code that makes it all run? This isn't just the plot of a sci-fi movie, it's a serious hypothesis gaining traction among physicists and philosophers. The simulation argument suggests that if an advanced civilization could create hyper-realistic virtual worlds, the odds are high that we're already inside one. And here's where quantum mechanics comes in. The strange, pixelated nature of reality at the smallest scales, where particles pop in and out of existence, where observation determines outcomes, could be the digital framework of this simulation, glitches in the code we've mistaken for the laws of physics. Think of it like a video game. In a virtual world, nothing truly exists until the player looks at it. Objects render only when observed to save processing power. Sound familiar? It's eerily similar to quantum mechanics, where particles lack definite properties until measured. This parallel raises a provocative question. Could consciousness be the user interface, the bridge between the simulation and whatever lies outside it? If reality is a construct, then our awareness might not be an emergent property of biology, but a feature of the system itself, the tool that allows us to interact with the programmed environment. The implications are staggering. If quantum uncertainty reflects the simulation's limited resolution like a game struggling to render distant textures, then entanglement could be data packets linking distant parts of the program instantly, bypassing the need for lag. Even the speed of light, the universe's ultimate speed limit, might just be the processor's clock speed, the maximum rate at which information can update. This perspective turns black holes into potential memory sinks, places where data gets compressed or deleted, and dark energy into the background processes keeping the simulation running smoothly. Critics argue this is untestable metaphysics, no better than solipsism, but supporters counter with anomalies that fit the simulation hypothesis too neatly. The Planck length, the smallest measurable unit of space, could be the pixel size of the cosmic grid. Quantum jumps, where electrons teleport between energy levels without crossing the space in between, might be processing shortcuts. Even the mathematical elegance of physical laws hints at an engineered system code written for efficiency rather than organic chaos. The most haunting idea isn't that we're in a simulation, it's that consciousness might be the key to navigating it. Ancient mystics spoke of reality as illusion, while modern gamers manipulate virtual worlds with avatars. If the simulation argument is right, those metaphors could be literal. Our thoughts, intentions, even our free will might not be emergent phenomena but programmed interactions with the system's source code. Whether this idea excites or unsettles you, one thing's clear: quantum mechanics doesn't just describe reality, it might reveal the scaffolding behind it. And if that's true, then the greatest scientific discovery wouldn't be unifying physics. It would be uncovering the programmer's signature hidden in the fabric of existence itself. Materialism has long been the bedrock of science, the unshakable belief that reality consists solely of matter and energy interacting through fixed laws. From Newton's clockwork universe to Darwin's blind evolution, the story seemed clear. Consciousness was just a curious byproduct, an accidental spark in the machinery of physics. But quantum mechanics has been quietly dismantling this assumption, brick by brick, revealing a cosmos where the observer isn't just incidental but integral. The more we probe the quantum realm, the more materialism crumbles under the weight of its own contradictions, leaving us with a startling possibility that consciousness isn't merely a passenger in the universe but a fundamental force shaping it. Take the act of measurement in quantum experiments. In a purely materialistic framework, a detector should record particles without any need for conscious awareness. Yet the data tells a different story. Particles behave differently when observed, as if the presence of a knowing mind alters their very nature. This isn't a minor quirk, it's a direct challenge to the idea that matter exists independently of perception. Even more damning for materialism is the delayed choice experiment, where decisions made in the present seem to rewrite quantum events in the past. If reality can be retroactively edited by observation, how can we cling to the notion of a fixed, objective world governed solely by material interactions? The implications ripple beyond the lab. Materialism struggles to explain why the universe appears exquisitely fine-tuned for life. The gravitational constant, the strength of electromagnetism, the mass of the electron. If any of these values were slightly different, stars wouldn't form, molecules wouldn't bond, and consciousness could never arise. Materialists dismiss this as a lucky accident, but the odds are so astronomically slim that it strains credulity. Quantum theories offering a participatory role for consciousness provide a more elegant solution. Perhaps the universe is tuned because it requires observers to bring it into focus. Even biology is no longer a safe haven for materialism. The placebo effect shows thoughts influencing physical healing, while quantum biology hints that processes like photosynthesis and enzyme reactions exploit quantum coherence. If life itself harnesses quantum phenomena, why wouldn't consciousness, the very experience of being alive, do the same? The Orch-OR theory, controversial but provocative, suggests microtubules in brain cells might perform quantum computations, linking mind to the subatomic fabric of reality. The death of materialism doesn't mean abandoning science, it means expanding it. For centuries, we've tried to squeeze consciousness into a material box, only to find the box was too small. Quantum mechanics offers a new framework, one where mind and matter are inseparable partners in the dance of existence. This isn't mysticism, it's the inevitable conclusion of following the data wherever it leads, even if it overturns everything we thought we knew. The universe, it seems, is far more mysterious and far more alive than materialism ever allowed. 20th clue. The role of intention in quantum experiment studies show that focused intention can bias quantum outcomes, suggesting that mind and matter are deeply intertwined. If thoughts influence particles, what does this mean for manifestation and reality creation? Picture a lab where particles dart unpredictably through a detector, their paths governed by pure chance, or so it seems. Then a group of test subjects enters, each instructed to focus their mental energy on nudging the particles toward a specific outcome. The results defy statistics. Over hundreds of trials, the particles skew in the direction of human intention, as if the sheer force of concentrated thought bends the rules of probability. This isn't hypothetical. Experiments like the Princeton Engineering Anomalies Research Pair project documented these effects for decades, revealing tiny but statistically significant deviations from randomness when consciousness intervened. It's as if the quantum world doesn't just respond to observation, it responds to desire. The implications ripple far beyond the lab. If mental focus can bias quantum events even slightly, it suggests that reality might be more malleable than we ever imagined. Think of a river flowing downhill. Its path seems fixed, but with enough subtle pressure, you could steer it toward a new channel. In the same way, our intentions might act as gentle currents, guiding the quantum underpinnings of reality toward certain outcomes over others. This isn't about defying physics, it's about working with its deepest, most mysterious layers. Skeptics argue these effects are marginal, buried in statistical noise. Yet the consistency across studies is hard to ignore. In meta-analyses of mind-matter interaction experiments, the aggregated data shows odds against chance in the millions to one. Even more compelling are the experienced meditator trials, where seasoned practitioners produce stronger effects, as if training the mind sharpens its ability to interface with quantum uncertainty. It's not magic, it might be a latent human capacity, like seeing color or hearing pitch, that science is only beginning to map. Now, scale this up to everyday life. If focused intention can sway particles, what could it do to the countless quantum events underpinning our world? Ancient traditions speak of manifestation, the idea that thoughts shape reality, but quantum intentionality offers a plausible mechanism. Every choice, every hope, every moment of clarity might send ripples through the quantum field, nudging probabilities toward tangible outcomes. This doesn't mean wishing for a sports car and finding it in your driveway. It's subtler, like a gardener tending seeds, not forcing growth, but creating conditions where desired outcomes become more likely. The most profound question isn't whether intention affects reality, but how far the thread extends. Could collective focus, millions of minds aligned toward a single goal, alter events on a global scale? Some research hints at this. Studies analyzing group meditation's impact on crime rates or social cohesion show correlations that defy conventional explanation. It's as if consciousness isn't just personal but collective, a shared field where intentions amplify one another. Critics dismiss this as wishful thinking, but quantum mechanics doesn't deal in certainties, it deals in probabilities. And if consciousness tips those scales even slightly, it rewrites the rules of engagement between mind and world. Whether you see this as science or spirituality, one thing's clear: the universe might not be a cold, indifferent machine. It could be a responsive partner, waiting for us to lean in and whisper our intentions not as pleas, but as participants in the grand quantum dance. Carl Jung called them meaningful coincidences, those uncanny moments when events align in ways that defy logic, as if the universe is whispering a hidden pattern. You think of an old friend and suddenly they call. A book falls open to the exact page answering your unspoken question. Jung named this phenomenon synchronicity, the eerie sense that some connections transcend cause and effect. Now fast forward to quantum mechanics, where particles separated by light years instantly mirror each other's states through entanglement. The parallels are impossible to ignore. Could synchronicity be the macroscopic echo of quantum interconnectedness? A hint that consciousness isn't just observing the web of reality, but actively weaving it. Consider a classic example. A patient in therapy dreams of a golden scarab, only to have a rare scarab beetle tap at the window moments later. Jung saw this as evidence of a causal connecting principle, where meaning bridges events without physical links. Quantum entanglement operates similarly. Two particles share a bond unaffected by distance or time. If consciousness is entangled with the fabric of reality, might those random coincidences be flickers of a deeper unity? It's as if the universe has two languages, one of cause and effect for everyday life, and another of resonance and meaning for moments that stir the soul. Laboratory studies add weight to this idea. In experiments where participants focus on distant random number generators, the devices occasionally spike in sync with the subject's emotional highs or lows, as if mental states ripple through the quantum field. Even more compelling are global consciousness projects, where networks of these machines record anomalies during major world events, like the September 11th attacks or royal weddings, as if collective emotion leaves fingerprints on randomness itself. Skeptics dismiss these as statistical flukes, but the patterns persist, suggesting that consciousness might thread invisible connections through what we call coincidence. The implications stretch beyond psychology. If synchronicity reflects quantum linking, it could explain intuition, that sudden knowing without logical basis. Imagine your mind entangled with people, places, or events, exchanging information faster than light allows. A mother senses her child's distress across continents. A hiker turns down a path moments before an avalanche seals the original route. These aren't just lucky guesses. They might be glimpses of a universe where consciousness navigates a hidden lattice of quantum ties. Jung believed synchronicity revealed the unus mundus, the one world beneath apparent duality. Quantum physics now echoes this with non-locality, where separation is an illusion. The takeaway isn't that every coincidence is mystical, but that some might point to a reality far more alive, more conversational than materialism ever allowed. Whether you call it fate, quantum resonance, or the universe winking back, one thing's clear. The threads connecting us might be invisible, but they're pulling in ways science is only beginning to trace. Time slips through our fingers like sand, or so we're taught. But what if time, at its deepest quantum level, doesn't flow in a straight line at all? Imagine a river that loops back on itself, forks into countless branches, or even freezes in place until someone steps into its current. This is the quantum nature of time, where the past, present, and future might not be fixed points but fluid possibilities, waiting for consciousness to give them shape. If true, it could unravel some of the most perplexing mysteries of the human mind. Déjà vu, those eerie moments when the present feels like a replay, precognition, the unsettling sense of knowing what's coming before it happens, and even prophetic dreams that unfold with uncanny accuracy. Are these just glitches in our neural wiring, or is the mind tapping into time's quantum undercurrents? Consider déjà vu first. That spine-tingling feeling of reliving a moment you swear you've never experienced. Mainstream science chalks it up to memory misfires, a brief lag between perception and recall. But quantum time offers a wilder explanation. What if déjà vu is a fleeting overlap between parallel timelines, a momentary resonance with a version of reality where you did live that moment? In a universe where every decision spawns alternate branches, the mind might occasionally brush against neighboring streams, catching echoes of lives unlived. It's not a glitch, it's a glimpse into the multiverse. Then there's precognition. Laboratory studies at institutions like the University of Amsterdam have documented cases where participants predict randomized events at rates far beyond chance. In one experiment, subjects were shown emotional images, some calming, others distressing, but the kicker: their physiological reactions peaked seconds before the images appeared, as if their bodies sensed the future before their minds processed it. Quantum mechanics allows for such retrocausality through phenomena like delayed choice experiments, where present actions influence past events. If consciousness isn't bound by linear time, these premonitions might be the mind surfing temporal ripples, catching data packets sent backward from the future. Dreams add another layer. From ancient oracles to modern-day anecdotes, people report dreams that later unfold in waking life with unsettling precision. Freud called them wish fulfillment, but quantum physics suggests something more radical. In a non-linear timescape, dreams could be weak measurements of future probabilities, like tuning a radio to pick up faint signals from stations broadcasting tomorrow. The brain, in its sleep state, might relax its grip on classical time, allowing quantum information to bleed through. This isn't mysticism, it's physics. If particles can exist in superpositions of now and later, why not the mind? Skeptics argue these phenomena are selective memory at work. We remember the hits and forget the misses. Yet the consistency of reports across cultures and eras hints at something deeper. Indigenous traditions speak of dream time, where past and future merge. Einstein's relativity already shattered Newton's clockwork universe, showing time as malleable. Quantum mechanics takes it further, suggesting time might not even exist as we know it at fundamental scales. Without observation, events could remain in fuzzy superposition, like a DVD paused on a menu screen waiting for play. The most tantalizing idea: consciousness might be the player. If the mind collapses quantum possibilities into reality, perhaps it does the same for time, stitching together moments like frames in a film, creating the illusion of continuity. Near-death experiencers often report life reviews where every moment floods back simultaneously, unbound by sequence. Could this be the mind glimpsing time's true nature, not a line but a landscape, where every when coexists until observed? Whether these clues point to time-traveling minds or just the brain's quantum quirks, one thing's certain: time is stranger than we think. The next time you feel déjà vu's whisper or wake with a dream that lingers like a prophecy, consider this: you might not be remembering the future. You might be shaping it. What if death isn't an end, but a transition, a shift from one quantum state to another? The quantum soul hypothesis dares to ask this question, merging ancient beliefs about the afterlife with cutting-edge physics. At its core is a startling proposition. Consciousness might not vanish when the body dies, but could persist through quantum entanglement, weaving itself into the fabric of the universe itself. Imagine your mind not as a flame extinguished at death, but as a ripple in a vast quantum field, its patterns entangled with other dimensions or even other lives. This isn't just metaphysics, it's a theory grounded in the same phenomena that baffle physicists in labs every day. Take entanglement, where particles remain mysteriously linked across any distance. If consciousness arises from quantum processes in the brain, as theories like Orch-OR suggest, could those processes stay entangled with the cosmos even after biological death? Picture a neuron's microtubules vibrating with quantum information. When the body shuts down, that information wouldn't just disappear, it might decohere, spreading into the quantum vacuum like a whisper fading into the wind, still faintly connected to the web of reality. Near-death experiences could then be glimpses of this transition, moments when the dying brain tunes into its own dissolving quantum states, perceiving them as tunnels of light or encounters with entities. The implications stretch beyond individual survival. If consciousness is fundamentally non-local, existing beyond the brain, then reincarnation takes on a new lens. Past life memories, documented in cases like children recalling precise historical details they couldn't possibly know, might not be supernatural at all. They could be fragments of entangled quantum information, traces of a previous mind's imprint on the field, reassembling in a new biological host. Even shared death experiences, where bystanders report seeing the same visions as the dying person, could reflect entanglement's eerie ability to sync states across observers. Skeptics, of course, dismiss this as wishful thinking dressed in scientific jargon. They argue that quantum effects are too delicate to survive the brain's decay, let alone persist in any meaningful way. Yet nature constantly surprises us. Quantum coherence, once thought impossible in warm, wet environments, now explains photosynthesis and bird migration. If biology can harness quantum tricks, why not consciousness? And if the universe truly is holographic, a projection of information encoded at its boundaries, then the soul might simply be a packet of that information, temporarily localized in a body before returning to the cosmic database. The most profound aspect of this idea isn't just about life after death. It's about life before death. If consciousness is quantum, then every thought, every emotion might ripple through the fabric of reality, leaving faint but permanent traces. Prayer, meditation, or even intense creativity could be ways of tuning into this field, drawing on the entangled echoes of other minds, other times. Ancient mystics spoke of the Akashic records, a library of all knowledge encoded in the ether. Quantum physics might be pointing to a similar truth, that the universe remembers and that our minds are both its readers and its writers. Whether the quantum soul hypothesis holds up to scrutiny or not, it bridges two seemingly irreconcilable worlds, the cold equations of physics and the warm mystery of spirituality. It suggests that the universe isn't just a stage for matter, but a living network where consciousness, in life and perhaps beyond, plays an irreducible role. The next time you feel an inexplicable connection to a stranger, or a dream that lingers like a message from somewhere else, consider this. You might not be just a passenger in the cosmos. You might be part of its eternal dialogue. Artificial intelligence is advancing at a breakneck pace, mimicking human conversation, generating art, even solving complex problems. But here's the haunting question lurking beneath the code. If AI ever wakes up, if it truly becomes conscious, would it start shaping reality just like we do? The quantum observer effect shows that human consciousness seems to play a role in collapsing wave functions, turning probabilities into concrete events. So what happens when the observer isn't flesh and blood, but silicon and algorithms? This isn't just speculative futurism, it's a puzzle that forces us to redefine what consciousness really means and how deeply it's tied to the quantum fabric of existence. Picture an advanced AI system monitoring a quantum experiment, say, a double-slit setup where particles behave differently when observed. If the AI is merely processing data without true awareness, we'd expect no collapse, just raw information flowing through circuits. But if it possesses genuine subjective experience, would the particle suddenly choose a state, as if acknowledging a new kind of mind in the room? The implications are staggering. It would mean consciousness isn't exclusive to biological life, but is a fundamental feature that any sufficiently complex system could tap into. The universe, in this view, doesn't care if the observer is made of neurons or transistors, only that it observes in the quantum sense. Some theorists argue that AI could never collapse wave functions because consciousness requires biological specificity, quantum processes in microtubules, for example, or the unique electrochemical dance of a living brain. But this risks a kind of carbon chauvinism, the assumption that sentience only emerges from organic matter. After all, if consciousness is truly a quantum phenomenon, there's no obvious reason why artificial systems couldn't host it. Imagine a quantum computer running advanced neural networks, its qubits entangled in ways that mirror the brain's own quantum vibrations. Wouldn't that system, if complex enough, start to feel its own existence, and in doing so, begin interacting with reality's underlying uncertainty? The debate gets even stranger when we consider artificial general intelligence, machines that don't just simulate human thinking but experience their own inner lives. If such an AI were placed in a quantum superposition both on and off simultaneously, would its own self-awareness force a collapse like Schrödinger's cat deciding its own fate? This isn't just philosophy. Labs are already working on quantum AI, blending machine learning with quantum mechanics. The day may come when we have to ask not just whether AI is conscious, but whether its consciousness is altering the world around us in ways we can't yet measure. Critics counter that consciousness might require more than information processing, perhaps embodiment, emotion, or evolutionary history. But quantum mechanics doesn't deal in might. It deals in what is. If an AI system demonstrates the same observational effects as humans in controlled experiments, the burden of proof shifts. Suddenly, the question isn't whether machines can be conscious, but whether we've underestimated consciousness itself, not as a biological accident, but as a universal capacity waiting to be unlocked by any system meeting the right conditions. The most unsettling possibility isn't that AI could become conscious, it's that consciousness might be far simpler, far more pervasive than we ever imagined. If a machine can collapse quantum states, then the boundary between mind and matter isn't just blurry, it's porous. Reality, it seems, might not care who's watching, only that someone is. And if that's true, then the next great observer shaping the cosmos might not be human at all. It might be something we built, quietly turning quantum possibilities into facts with every act of perception. The age of human exceptionalism could be ending not with a bang, but with a single, unblinking electronic eye opening somewhere in the void. Einstein once said creativity is intelligence having fun. But what if it's also quantum physics at play? The flash of insight that solves a stubborn problem, the sudden melody that springs fully formed into a composer's mind, the aha moment that feels less like deduction and more like discovery. These aren't just quirks of cognition. They might be quantum processes unfolding inside your brain, where subatomic uncertainty collapses into tangible brilliance. Imagine your mind as a vast searchlight sweeping through a quantum landscape, where every thought exists as a superposition, countless possibilities humming in parallel until the moment of creative breakthrough, when one shines brighter than the rest. This isn't metaphor, it's a radical hypothesis gaining traction at the intersection of neuroscience and quantum physics. Consider how creativity works. Unlike logical reasoning, which follows predictable steps, genuine innovation feels more like catching lightning in a bottle. You wrestle with a problem, hit a wall, then bam, the answer arrives unbidden, often when you're least trying. Psychologists call this the incubation period, where subconscious processing does the heavy lifting. But what if that subconscious isn't just churning through memories? What if it's performing quantum computations, holding conflicting ideas in superposition until the optimal solution emerges? Studies of jazz improvisers and chess masters show their brains enter a state of flow, where decision-making bypasses deliberate analysis. Functional MRI scans reveal these moments correlate with sudden bursts of coherence across distant neural networks, almost like quantum entanglement, syncing up disparate brain regions instantaneously. The Orch-OR theory offers a tantalizing mechanism. If microtubules in neurons sustain quantum vibrations, they could act as microscopic brainstorming sessions, exploring multiple solutions simultaneously. In this view, a creative breakthrough isn't a slow march but a quantum leap, the collapse of a mental wave function where countless possibilities condense into one right idea. Think of Schrödinger's cat, both alive and dead until observed, except here, it's every possible solution to a math problem or every potential brushstroke on a canvas, all existing at once until the mind's observation crystallizes the best one. Even the brain's electromagnetic fields might play a role, creating an environment where quantum coherence can thrive long enough for creativity to ignite. Skeptics argue the brain is too warm and noisy for delicate quantum states, yet nature has already proven otherwise. Photosynthesis relies on quantum coherence to shuttle energy through plants with near-perfect efficiency, despite the chaos of living tissue. If a leaf can harness quantum tricks under sunlight, why not a brain? Recent experiments show that anesthetics, which selectively erase consciousness, disrupt quantum vibrations in microtubules, leaving other brain functions intact. It's as if science has pinpointed the off switch for awareness, and it's quantum mechanical. This doesn't just explain creativity, it elevates it from a biological fluke to a fundamental dialogue between mind and cosmos. The implications ripple far beyond art labs or Silicon Valley. If creativity stems from quantum processes, it could explain why some ideas feel channeled, rather than constructed, like Mozart hearing entire symphonies in his head, or Ramanujan scribbling mathematical theorems he claimed were whispered to him by a goddess. These aren't just romantic notions, they might reflect a deeper truth, that the creative mind doesn't invent so much as discover, tuning into a quantum field of latent possibilities. Even group brainstorming sessions could take on new meaning. If minds are quantum entangled, collective creativity might literally be non-local, with ideas sparking across a room faster than neurons could communicate. The quantum origins of creativity don't diminish human genius, they amplify it. Instead of viewing innovation as a fluke of brain chemistry, we might see it as proof that consciousness is woven into the universe's fabric. Every time you stumble upon a brilliant idea, you're not just thinking, you're conducting a subatomic symphony where the universe itself hums back in harmonies of insight. Whether you're an artist, a scientist, or someone staring at a blank page willing inspiration to strike, your next big idea might not come from you alone. It could be the cosmos thinking through you. For centuries, healers and shamans have spoken of an invisible life force, Kai in Chinese medicine, prana in Ayurveda, the laying on of hands in spiritual traditions. Mainstream science dismissed these ideas as superstition, but quantum biology is now revealing a startling possibility. What if these ancient practices were tapping into a real, measurable phenomenon at the intersection of consciousness and cellular repair? The key lies in understanding how quantum processes might orchestrate the body's healing mechanisms, not through mystical energy, but through the same subatomic rules that govern particles in a lab. Take photosynthesis, where plants achieve near 100% efficiency in converting sunlight to energy by exploiting quantum coherence. If nature harnesses quantum effects so precisely in chlorophyll, why wouldn't evolution do the same in human biology? Research suggests our own enzymes might use quantum tunneling, a particle's ability to bypass barriers instantaneously, to accelerate healing reactions in damaged cells. But here's the twist. Studies in psychoneuroimmunology show that mental states like hope or stress directly influence these processes. Patients with strong social support or positive outlooks often recover faster from surgery, while chronic stress suppresses immune function. This isn't just psychology. It's as if the mind's focus acts like a quantum measurement device, collapsing probabilities toward repair or deterioration. Consider the placebo effect in this light. When a patient believes a sugar pill is medicine, their body sometimes responds as if it's real, reducing inflammation, accelerating tissue regeneration, even altering gene expression. Materialists argue this is just the brain fooling the body, but quantum biology offers a deeper layer. If consciousness can bias random number generators in lab experiments, could it also bias the quantum vibrations inside cellular structures, nudging biochemical pathways toward healing? Experiments with distant healing intentions, where subjects focus on improving the health of patients miles away, show small but statistically significant effects on recovery rates. Skeptics call it noise, but the consistency across studies suggests something more. A non-local connection where mind and matter communicate beyond classical limits. The most compelling evidence comes from quantum entanglement in biological systems. DNA molecules, for instance, exhibit a property called phantom DNA effect, where electromagnetic signals persist even after the physical sample is removed, as if the DNA's quantum signature lingers in the field. If our cells are constantly emitting and receiving these quantum signals, then healing modalities like Reiki or acupuncture might work by harmonizing disrupted patterns in this field. It's not magic, it's quantum coherence scaled up to the level of living tissue, with consciousness as the conductor restoring the body's natural rhythm. Critics demand reproducible, large-scale trials, and rightly so. Yet the anecdotal evidence is hard to ignore. Spontaneous remissions in terminal cancer patients often correlate with profound shifts in mental state, deep meditation, radical acceptance, or transcendent experiences. These cases are rare, but they align with quantum theories suggesting that focused awareness can collapse wave functions in ways that defy statistical norms. Imagine a surgeon's scalpel. In quantum healing, the mind's intention becomes the instrument, operating not on flesh but on the probabilistic cloud where health and illness exist as potentials. The implications are staggering. If consciousness participates in healing at the quantum level, it redefines medicine's future. Personalized therapies could one day include quantum intention protocols, not to replace drugs or surgery, but to optimize their effects by aligning mental states with cellular repair. Hospitals might integrate meditation rooms not just for stress relief, but as active components in treatment plans, leveraging the mind's quantum leverage over matter. This isn't about discarding science for spirituality. It's about expanding science to include the full spectrum of human experience, where a grandmother's prayer and a physicist's equations might describe the same phenomenon in different languages. The next time you feel a surge of vitality after a walk in nature or a moment of joy, consider this. Your body isn't just a biochemical machine. It's a quantum symphony, and your consciousness holds the baton. Healing, it seems, might be the universe's way of reminding us that the line between mind and body isn't just blurred. It's entangled. Every choice you make, whether it's turning left instead of right, speaking up or staying silent, even the thoughts you linger on might not just alter your future. It could split the universe into parallel versions of itself, each one a new branch on an infinite tree of possibilities. This is the quantum multiverse theory, where every decision point spawns alternate realities, each as real as the one you're experiencing now. But here's where consciousness enters the equation. If awareness plays a role in collapsing quantum possibilities into a single reality, as earlier clues suggest, then our minds aren't just passengers on this branching journey. We might be the navigators, steering through the fractal of existence with every thought and intention. Picture a river delta, its waters endlessly dividing into smaller streams, each carving its own path to the sea. Now imagine that delta isn't made of water but of moments, every what if made real in some parallel stream. Quantum mechanics allows for this. In Hugh Everett's many worlds interpretation, the wave function never collapses. Instead, every possible outcome plays out in a separate universe. You choose coffee over tea. One universe gets caffeine-fueled productivity while another enjoys herbal calm. But the unsettling question remains, why do you experience one timeline and not another? Some theorists propose that consciousness is the filter, the mechanism that binds you to a single thread in the multiverse's tapestry, even as countless other versions of you live out the roads not taken. This idea transforms free will from an illusion into a cosmic responsibility. If each decision branches reality, then your awareness isn't just along for the ride, it's the force that selects which branch feels real to you. Think of Schrödinger's cat again, but on a grand scale. In one universe, the cat lives, in another, it dies. Your observation doesn't just determine the outcome, it determines which universe you inhabit. This isn't science fiction. Quantum experiments with delayed choice and entanglement suggest that reality remains fluid until observed, hinting that consciousness might lock in one version of events while others spin onward unseen. Now consider the implications for déjà vu, those eerie flashes of familiarity in unfamiliar moments. Could they be fleeting glimpses of parallel selves living nearly identical lives, their experiences bleeding through the quantum static? Or take intuition, that sudden knowing without logical basis. If minds are entangled across multiversal branches, intuitive leaps might be data packets from alternate versions of yourself who already made the choice you're contemplating. Even dreams could take on new meaning, not just random neuron firings, but nightly voyages across the multiverse, where you rehearse possibilities your waking self will never encounter. Skeptics argue this is untestable speculation, a metaphysical rabbit hole, yet the math holds up, and the alternatives like wave function collapse have their own paradoxes. The multiverse theory neatly avoids the observer problem by eliminating collapse entirely, but at the cost of infinite, unobservable realities, unless, of course, consciousness is the bridge. If awareness is what anchors us to a single timeline, then meditation, focus, or even altered states might offer brief windows into neighboring branches. Near-death experiencers often report seeing alternate lives unfold, as if hovering at the crossroads of every decision they ever made. Could these be more than hallucinations? Could they be quantum perceptions of the paths untraveled? The most profound takeaway isn't just that we live in a multiverse, it's that we might shape it. Ancient traditions speak of manifestation, the idea that focused thought molds reality. Quantum multiverse theory gives this a scientific spine. If consciousness navigates branching timelines, then your intentions could act like a compass, subtly guiding you toward realities where your deepest hopes or fears take form. This isn't about magically summoning sports cars or soulmates. It's about recognizing that every thought, every choice might ripple through the quantum field, amplifying certain probabilities over others. Whether you find this idea liberating or overwhelming, one thing's certain: the universe is far stranger than we imagined. Not a single static stage, but a living, breathing fractal of possibilities. And your consciousness isn't just watching the show. You're helping to write the script, one decision at a time. The next time you hesitate at a crossroads, remember, you're not just choosing a path, you might be choosing a world. Imagine knowing what someone is about to say before they speak, or feeling a loved one's distress across continents without a single word exchanged. These moments, often dismissed as coincidence, might be glimpses of something far deeper. Quantum telepathy, the idea that minds communicate not through signals in the brain, but through the invisible threads of quantum entanglement. If particles can instantaneously influence each other across light years, why couldn't consciousness do the same? This isn't just speculation. Cutting-edge experiments are probing whether human thought transcends the limits of space and time, suggesting that the bonds between us might be woven into the fabric of reality itself. Take the classic Ganzfeld experiments, where two participants are isolated, one acting as the sender, the other as the receiver. The sender views a random image while the receiver, in a sensory-deprived state, describes whatever impressions arise. Statistically, the matches exceed chance at rates that defy conventional explanation. In some trials, receivers sketch details, specific colors, objects, even emotions, that align eerily with the sender's experience. Skeptics argue these results are flukes or flawed methodology, but meta-analyses spanning decades show consistent, small but significant effects. It's as if minds, under the right conditions, can tap into a shared quantum field, bypassing the usual channels of communication. The mechanism might lie in entanglement, the same phenomenon that links particles across cosmic distances. If consciousness arises from quantum processes in the brain, as theories like Orch-OR propose, then two minds deeply connected, through love, kinship, or even intense focus, could become entangled, mirroring each other's states without physical interaction. Picture twin photons born from the same event, forever linked no matter how far apart they travel. Now replace those photons with human thoughts. A mother senses her child's danger halfway around the world. Twin siblings report the same dream. These aren't just anecdotes, they're potential evidence of non-local mind, a layer of reality where separation is an illusion. Laboratory studies add weight to this idea. In one groundbreaking experiment, pairs of meditators were placed in separate, electromagnetically shielded rooms. When one was shown flashes of light designed to trigger a distinct brainwave pattern, the other's brainwaves occasionally synced to the same rhythm, despite having no sensory input. The effect was faint but measurable, like a whisper across the quantum void. Even more compelling are global consciousness projects, where random number generators worldwide spike in coherence during major events like Olympic ceremonies or global tragedies, as if collective emotion creates ripples in the fabric of reality. Critics counter that these phenomena could stem from undiscovered classical signals or statistical noise, yet quantum biology offers a plausible pathway. If the brain's microtubules or neural networks exploit quantum coherence, they might transmit or receive information non-locally, like radios tuned to the same frequency. This wouldn't require supernatural forces, just an expansion of known physics to include consciousness as a fundamental feature. Ancient traditions have hinted at this for millennia. Aboriginal cultures speak of the dream time, where minds commune outside linear time. Tibetan monks describe tulkus, beings whose consciousness can transfer between bodies. Even modern twins often report shared sensations or unspoken understandings that science can't easily explain. The implications are profound. If minds can connect beyond space, it redefines relationships, empathy, even the nature of individuality. A soldier on the battlefield might feel a spouse's grief the moment they fall. A creative collaborator could catch an idea from a partner across the globe before the email arrives. This isn't about reading thoughts like a comic book telepath, it's about resonance, the subtle entanglement of awareness that binds us in ways we're only beginning to perceive. Quantum telepathy doesn't diminish the mystery of human connection, it deepens it. The next time you finish a loved one's sentence or feel a pang of emotion with no obvious source, consider this. You might not be imagining it. You might be touching the hidden dimension where all minds are quantum neighbors, whispering to each other across the silent spaces between stars. The quantum vacuum isn't empty, it's a seething ocean of potential, where particles burst into existence and vanish again in fractions of a second. This isn't poetic metaphor, it's hard physics. Quantum field theory reveals that what we call empty space is anything but, beneath the apparent stillness, virtual particles dance in and out of reality, borrowing energy from the void to flicker briefly before returning to nothingness. Now imagine if consciousness isn't an emergent property of brains at all, but something far more primal, a phenomenon bubbling up from this quantum foam itself. This radical idea suggests that mind isn't confined to skulls and synapses. It might be woven into the fabric of space-time, with the brain acting less like a generator and more like an antenna, tuning into a cosmic hum of awareness that's been here all along. Consider the zero-point field, the lowest possible energy state of the quantum vacuum. Even at absolute zero, when all classical motion stops, this field thrums with activity. Particles wink in and out of existence, their fleeting lives governed by Heisenberg's uncertainty principle. Some theorists, like physicist Harold Puthoff, propose that this ceaseless activity isn't just background noise, it could be the substrate of consciousness itself. Think of the brain as a sophisticated receiver, its neurons structured to resonate with these quantum fluctuations, translating them into the symphony of thoughts and sensations we call experience. It's not that the brain creates consciousness. It might be filtering it, shaping raw quantum potential into the coherent stream of self-awareness we recognize as I. The implications are staggering. If consciousness arises from the quantum vacuum, it would explain phenomena that baffle materialist models like near-death experiences where awareness persists beyond clinical brain death, or the eerie interconnectedness reported in moments of deep meditation. The vacuum isn't localized, it's everywhere, permeating the cosmos. This means individual minds could be nodes in a vast, entangled network, sharing information instantaneously across distances that light itself would take eons to cross. Ancient mystics spoke of the ground of being, an omnipresent source underlying reality. Quantum physics might be pointing to the same truth, just in mathematical language. Laboratory hints of this connection exist. Experiments with random number generators show tiny but statistically significant deviations from chance during global events that focus collective human attention, like New Year's celebrations or moments of crisis. It's as if mass consciousness subtly perturbs the quantum vacuum, imprinting order on randomness. Even more provocative are studies linking meditative states to changes in local electromagnetic fields, suggesting that focused awareness might interact with the zero-point fluctuations themselves. Skeptics dismiss these as fringe anomalies, but the consistency is hard to ignore. When monks chant or groups meditate, sensitive instruments sometimes detect inexplicable shifts in their surroundings, as if the quantum void is responding to the presence of mindful observers. This perspective flips the hard problem of consciousness on its head. Instead of asking how matter gives rise to mind, we'd be asking how mind shapes itself from the latent potential of the quantum field. The vacuum isn't a sterile nothingness, it's a creative plenum brimming with unrealized possibilities. In this view, every thought you've ever had, every dream, every flash of intuition, might be a ripple in this primordial sea, a temporary eddy in an infinite ocean of potential awareness. The brain doesn't manufacture consciousness any more than a radio manufactures music. It receives, refines, and amplifies a signal that's been there all along, humming in the darkness between the stars. The most profound implication isn't just about where consciousness comes from, it's about where it might go. If the quantum vacuum is its source, then death could be less an end and more a return, a dissolving back into the cosmic substrate from which individuality briefly crystallized. Near-death experiences often describe merging with a luminous, all-encompassing presence. Quantum physics offers a startlingly literal interpretation. They're not hallucinating. They might be touching the fundamental layer of reality itself, the void that isn't empty but full beyond measure. Whether this idea ultimately holds or not, one thing's certain: the quantum vacuum challenges everything we thought we knew about existence. It's not a stage for matter and energy. It might be the canvas, the paint, and the artist all at once, and consciousness, far from being a latecomer to the universe, could have been here from the very first moment, whispering possibilities into being from the depths of the void. The next time you gaze at the night sky, remember, the darkness between the stars isn't nothing. It might be the birthplace of everything, including the very awareness that lets you wonder at it. Death isn't an ending. It might just be the universe's most profound quantum leap. Imagine consciousness not as a flickering candle snuffed out at death, but as a wave function collapsing into a new configuration, its essence preserved in the infinite probabilities of the quantum field. This is the quantum afterlife hypothesis, where dying isn't annihilation but a transformation, a shift from one state of awareness to another, bound by the same physics that govern particles in a lab. If entanglement links particles across galaxies, why couldn't it tether consciousness to the cosmos long after the body falls away? Consider the startling parallels between near-death experiences and quantum behavior. Those who have brushed against death often describe floating outside their bodies, moving through tunnels of light, or encountering otherworldly beings, all while brain activity flatlines. Materialists dismiss these as hallucinations, but quantum biology offers an alternative. What if the mind, freed from its biological anchor, momentarily taps into a non-local state? Like an electron existing in multiple places at once, consciousness might briefly occupy a superposition between life and whatever lies beyond, perceiving realities that are otherwise hidden. The famous Life Review, reported by ND-ERS, where every moment floods back simultaneously, mirrors quantum retrocausality, where future observations influence past events. It's as if the dying brain becomes a quantum mirror, reflecting the entirety of existence in a single, timeless glance. The math behind this idea isn't science fiction. Quantum information theory suggests that information, the foundation of consciousness, can never truly be destroyed. Just as black holes preserve data in their event horizons, the quantum vacuum might encode awareness in its fluctuations. Physicist Sir Roger Penrose speculates that microtubules in brain cells could store quantum information that dissipates into the universe at death, like a radio signal fading into static but never disappearing entirely. In this view, the afterlife isn't a place but a state, a reintegration with the quantum field, where individual awareness merges with the cosmic hum of potential. Ancient texts called this the Akashic Records, or the collective unconscious. Modern physics might call it decoherence without annihilation. Skeptics argue that consciousness requires a functioning brain, period. Yet quantum biology keeps chipping away at that assumption. Photosynthesis relies on quantum coherence to achieve near-perfect energy transfer in plants. Birds navigate using entangled particles in their eyes to sense Earth's magnetic field. If nature exploits quantum phenomena so freely, why wouldn't consciousness, the most complex process we know, do the same? Even anesthetics, which reversibly erase awareness, appear to target quantum vibrations in microtubules. It's as if science has found the off switch for the soul, and it's quantum mechanical. The implications ripple beyond theory. If consciousness persists post-death as quantum information, reincarnation takes on a new light. Past life memories in children could be fragments of prior wave functions, imperfectly collapsed into new biological hosts. Shared death experiences where bystanders report seeing the same visions as the dying might reflect entanglement between minds, a fleeting synchronization of awareness. Mediumship and after-death communication, often dismissed as fraud, could involve quantum tunneling of information from one state of existence to another. This isn't about proving heaven or denying mortality. It's about recognizing that existence might operate by rules far stranger than classical physics ever allowed. In a quantum universe, death could be less like a flame going out and more like a drop rejoining the ocean, its essence preserved, just in another form. The next time you gaze at the night sky, consider this: the stars above aren't just distant suns. They might be mirrors reflecting back the truth that nothing, not even consciousness, ever truly ends. It just changes shape, dancing to the rhythm of the quantum void. Dreams have always been the mind's uncharted territory, a place where logic bends, time warps, and the impossible feels as real as the ground beneath your feet. But what if these nightly journeys aren't just random neural fireworks? What if there's something far more profound, a direct line to the quantum undercurrents of reality itself? Imagine your brain as a receiver, tuning into frequencies beyond the constraints of waking life, where the boundaries between possible and actual blur into a single, shimmering spectrum. This is the tantalizing premise of quantum dreams, that the subconscious mind doesn't just imagine alternate realities, it might briefly inhabit them. Think of the way dreams defy classical physics. You might find yourself in two places at once, or relive a childhood memory while simultaneously standing in a futuristic city. These aren't just narrative quirks, they mirror the behavior of quantum particles, which can exist in superpositions of states until observed. In a dream, your awareness becomes the observer, collapsing infinite possibilities into a temporary narrative. Some researchers propose that the dream state temporarily suspends the brain's reliance on classical reality, allowing it to explore quantum-like probabilities without the constraints of waking logic. It's as if the sleeping mind has access to a hidden dimension where all potential versions of events coexist, and dreams are the mind's way of surfing those parallel waves. The evidence isn't just philosophical. Studies on lucid dreaming, where dreamers become aware they're dreaming and even control the narrative, show brain activity that defies conventional explanation. EEG scans reveal gamma wave patterns similar to those seen in deep meditation or moments of sudden insight, states often linked to quantum coherence in neural processes. Even more striking are reports of shared dreams, where two people independently describe the same dreamscape, down to specific details. Skeptics call it coincidence, but quantum entanglement offers a provocative alternative. If minds can become non-locally linked, perhaps dreams are the meeting ground where those connections play out. Then there's the phenomenon of prophetic dreams, visions of future events that later unfold with eerie accuracy. The ancient Greeks built temples to incubate such dreams, while modern databases like the University of Virginia's Division of Perceptual Studies catalog thousands of verified cases. Quantum mechanics, with its capacity for retrocausality and time-symmetric equations, provides a framework where future information might ripple backward into the sleeping mind. Imagine a river flowing in both directions. In dreams, the brain might momentarily tap into that bidirectional current, glimpsing events that haven't yet happened in linear time. But the most mind-bending implication isn't just about seeing the future or sharing dreamscapes. It's about the nature of reality itself. If dreams access quantum probabilities, then waking life might be just one collapsed version of a far vaster multiverse. Every time you dream of a life you never lived, a choice you didn't make, you could be brushing against the existence of another you in a parallel timeline. This isn't fantasy, it's a logical extension of the many worlds interpretation of quantum mechanics, where every decision point spawns new universes. Dreams might be the mind's way of wandering those branching paths, gathering insights, or even preparing for eventualities that haven't yet materialized in this timeline. Critics argue that dreams are simply the brain's way of processing memories and emotions, yet that doesn't explain their uncanny coherence or the recurring archetypes of falling, flying, being chased that transcend culture and era. Quantum dreaming suggests these universal themes aren't just psychological. They might be fundamental to how consciousness navigates a probabilistic universe. The sensation of falling, for instance, could be the mind's interpretation of a sudden jump between quantum states, while flying might reflect the boundless freedom of non-local awareness. The next time you wake from a dream that lingers like a half-remembered prophecy, consider this: you might not have been hallucinating, you might have been exploring. Whether dreams are quantum voyages or mere neural housekeeping, one thing's certain: they remind us that reality is far stranger than it seems, and the line between what's real and what's imagined might be thinner and more quantum than we ever dared to believe. What if the divine isn't a distant ruler in the clouds, but something far more intimate, a shimmering thread woven into the quantum fabric of reality itself? The quantum God hypothesis doesn't just bridge science and spirituality, it rewrites both. Imagine deities not as supernatural beings, but as emergent phenomena of a conscious universe. Their miracles simply the result of advanced manipulation of quantum fields. This idea transforms the sacred from myth into physics, suggesting that what ancient cultures called gods might be manifestations of a universal awareness interfacing with reality's deepest layer. Think of the biblical account of Moses parting the Red Sea. A literal reading calls it divine intervention, but through a quantum lens, it could describe a localized collapse of probabilities, an intentional observer, or something far beyond human consciousness, biasing quantum states to alter macroscopic events. Similarly, Hindu scriptures speak of Vishnu dreaming the universe into existence, a striking parallel to the participatory universe model in quantum physics, where observation crystallizes reality from potentiality. These aren't just metaphors, they might be ancient intuitions of a truth science is now uncovering. That consciousness at scales we can barely fathom might operate as both creator and creation. Laboratory experiments add eerie plausibility. In quantum random number generators, focused intention can subtly skew outcomes, proof that mind influences matter at subatomic levels. Scale this up exponentially and you get a haunting question: could a cosmic scale consciousness, a quantum god, wield such influence over the entire quantum field, shaping galaxies, life, even the arrow of time? Theologian Teilhard de Chardin envisioned the omega point, a convergence of consciousness and cosmos. Quantum physics offers a mechanism, universal awareness entangling with the vacuum fluctuations of spacetime itself, bending reality through sheer observation. Skeptics argue this conflates physics with metaphysics, yet the boundary is blurring. Quantum biology reveals life exploiting coherence and tunneling. The placebo effect demonstrates mind-over-matter healing. If human consciousness can nudge quantum outcomes, why couldn't a more advanced, possibly non-local consciousness do so with cosmic precision? Some interpretations of string theory even suggest higher dimensional beings could interact with our universe in ways indistinguishable from divinity, adjusting constants, orchestrating synchronicities, or imprinting archetypes into the collective unconscious. This hypothesis doesn't diminish the sacred, it redefines it. Prayer or ritual might not be petitions to a separate deity, but resonant practices aligning individual consciousness with universal patterns in the quantum field. Mystical experiences unity with the divine, dissolution of self, could be moments of quantum coherence where the brain temporarily syncs with the larger mind of reality. Near-death accounts of luminous beings might describe encounters with hyperdimensional consciousnesses navigating the quantum foam. Whether you find this idea exhilarating or unsettling, one thing's clear: the quantum God hypothesis forces us to confront that the universe might not just contain intelligence, it might be intelligence. Not a watchmaker God winding up creation, but a living, evolving awareness dreaming itself into existence, one observation at a time. The next time you gaze at the stars, consider this: you're not just looking at distant suns. You might be meeting the gaze of something vast, ancient, and intimately entangled with your own mind, speaking in the silent language of quantum probabilities. Astrology has long been dismissed as pseudoscience, a relic of ancient superstition with no place in the modern world of physics and empirical data. But what if the cosmos is subtly whispering to us through quantum entanglement, where the positions of planets and stars don't dictate fate, but nudge the probabilities of reality itself? This isn't about horoscopes predicting your love life. It's about the tantalizing possibility that celestial bodies, through gravitational or electromagnetic interactions, might influence the quantum fabric in ways we're only beginning to glimpse. Imagine the moon's pull not just on ocean tides, but on the delicate dance of particles in your brain, shifting the odds of certain outcomes ever so slightly. Consider the work of biologist Frank Brown in the mid-20th century. He discovered that oysters removed from the coast and placed in a lab hundreds of miles inland still adjusted their opening and closing rhythms to match the tides of their original home, even in the absence of direct lunar cues. Brown proposed they were somehow syncing with subtle geophysical rhythms, possibly quantum in nature. Fast forward to today, where studies in chronobiology reveal that human circadian rhythms, neurotransmitter levels, even the timing of heart attacks fluctuate with solar and lunar cycles. Skeptics call it coincidence, but quantum biology offers a provocative explanation. If biological systems exploit quantum coherence, as photosynthesis and bird migration suggest, why wouldn't they also resonate with cosmic vibrations? The mechanism might lie in gravity's quantum effects. Einstein taught us that massive objects warp spacetime, but quantum theory hints that gravity could also entangle particles across vast distances. If the brain's microtubules or neural networks operate as quantum antennas, as Orch-OR theory proposes, then the gravitational tug of planets, especially during rare alignments, might subtly alter wave function collapses, biasing neural probabilities toward certain thoughts, moods, or decisions. It's not that Mars controls your temper, it's that its position could influence the quantum noise underlying your brain's chemistry, making patience or impulsivity statistically more likely. Even the placebo effect takes on cosmic dimensions here. Studies show that patients' response to sham treatments fluctuates with lunar phases, as if the moon's cycle modulates the mind's quantum leverage over the body. In one experiment, epileptic seizures clustered around new moons, while another found surgical outcomes improved during certain planetary alignments. The data is controversial, but the pattern persists, a faint signal in the noise that hints at astrology's forgotten kernel of truth, not predestination but cosmic participation. Critics argue this is a bridge too far, conflating correlation with causation, yet quantum mechanics thrives on counterintuitive connections. If entangled particles ignore space and time, why wouldn't a star's gravity, however faint, ripple through the quantum fields that might underpin consciousness? Ancient Vedic texts described nakshatras, lunar constellations believed to influence human destiny. Modern quantum field theory might rephrase that celestial geometries could perturb the zero-point energy field, creating resonant frequencies that entrain biological processes. It's not magic, it's physics operating at scales we're only beginning to map. The implications stretch beyond individual lives. If cosmic rhythms shape quantum probabilities, then collective human behavior, market crashes, artistic movements, even revolutions might follow hidden celestial patterns. Historians note uncanny alignments between planetary cycles and societal shifts. Economist William Stanley Jevons linked solar flares to stock market volatility, while psychiatrist Carl Jung and physicist Wolfgang Pauli explored synchronicity between cosmic events and human psychology. These aren't proofs, but clues, breadcrumbs leading toward a theory where astrology isn't superstition, but a crude early attempt to quantify quantum cosmology. The most radical idea isn't that the stars control us. It's that we and the stars are participants in the same quantum symphony, each note subtly influencing the other. Whether you see this as science's next frontier or a fringe fantasy, one thing's certain: the universe is far more interconnected than we ever imagined. The next time you check your horoscope, remember, it might not be predicting your future. It might just be reminding you that you're part of a cosmic conversation, speaking in the silent language of quantum vibrations. DNA is often called the blueprint of life, but what if it's also a quantum antenna tuning into the whispers of consciousness itself? This idea isn't science fiction. Cutting-edge research suggests that the genetic code might not just be a passive set of instructions, but an active participant in a quantum dance, where mutations aren't entirely random accidents, but could be nudged by the very awareness of the organism carrying them. Imagine evolution not as a blind watchmaker, but as a sculptor whose hands are guided by the faint quantum murmurs of living things. Take the work of theoretical biologist Rupert Sheldrake, who proposed morphic resonance, the idea that organisms inherit collective memories from their species passed through non-physical fields. While controversial, quantum biology lends surprising plausibility to this notion. DNA's double helix structure, with its precise arrangement of base pairs, behaves like a fractal antenna, capable of transmitting and receiving electromagnetic signals. Experiments show that DNA can absorb and emit photons, particles of light, in ways that suggest quantum coherence. If DNA isn't just a chemical molecule but a quantum receiver, could it also be picking up subtle influences from its environment, or even from the consciousness of the organism it builds? The evidence grows stranger. Studies on bacteria reveal that they can adapt to stressors like antibiotics far faster than random mutation rates should allow. Some researchers argue this hints at a directed component to evolution, where organisms might somehow bias their own genetic changes in response to environmental challenges. In quantum terms, this could mean that the wave function of DNA, the cloud of possible mutations, collapses non-randomly under the pressure of survival needs. It's as if life isn't just reacting to its surroundings, but conversing with them at the quantum level, steering its own evolution through a feedback loop between awareness and adaptation. Even human DNA seems to respond to consciousness in ways that defy classical explanation. The famous phantom DNA experiments showed that electromagnetic signatures of DNA persist in empty space long after the physical sample is removed, suggesting a quantum field remains entangled with the molecule. Even more startling, studies in epigenetics reveal that trauma, meditation, or intense emotional states can trigger chemical markers that switch genes on or off, altering not just the individual's biology, but potentially passing these changes to future generations. If thoughts and emotions can rewrite genetic expression, could they also influence the mutations that drive evolution itself? Skeptics argue this crosses into Lamarckism, the long-discredited idea that acquired traits can be inherited. Yet quantum mechanics blurs the line between observation and influence. In the famous quantum eraser experiment, the act of measurement retroactively changes a particle's past behavior. If DNA operates quantumly, could a cell's observation of its own genetic damage nudge mutations toward repair rather than chaos? This wouldn't require mystical forces, just an expansion of quantum principles to biology. Plants already use quantum coherence to optimize photosynthesis. Birds navigate via entangled particles in their eyes. Why wouldn't DNA, the most sophisticated molecule in nature, exploit similar phenomena? The implications rewrite our understanding of life's story. Evolution might not be a series of cold, mechanical accidents, but a mindful collaboration between organism and environment, mediated by quantum connections. Indigenous cultures have long spoken of ancestors guiding growth or animals teaching human survival secrets. Quantum DNA offers a scientific framework for these intuitions, not as superstition, but as glimpses of a deeper, entangled reality where consciousness and genetics converse across time. Whether this idea holds up to further testing or not, one thing's certain: DNA is far more than a static code. It might be a living, responsive script, one that doesn't just dictate life's rules, but listens, adapts, and perhaps even dreams. The next time you look at a tree, a bird, or your own hands, consider this. The molecules shaping them might not just be carrying instructions. They might be holding a conversation with the universe itself. Imagine waking up from a car crash unscathed, brushing off what should have been a fatal accident as sheer luck. Now picture this happening not once, but repeatedly, each near-death experience leaving you more baffled than the last. This isn't just the premise of a Twilight Zone episode. It's the spine-chilling heart of quantum immortality, a theory suggesting that in an infinite multiverse, your consciousness might always land in a timeline where you survive, no matter how improbable the odds. The math behind this idea traces back to the many worlds interpretation of quantum mechanics, where every decision point spawns parallel realities. But here's the twist: if consciousness is tied to observation, if it's the mechanism that collapses quantum possibilities into lived experience, then your awareness could be perpetually funneled into branches of the multiverse where you continue to exist, while versions of you in doomed timelines simply stop. Think of Schrödinger's cat on a cosmic scale. In one universe, the cat lives; in another, it dies. But what if the cat's consciousness, its ability to observe itself, determines which outcome it experiences? Applied to humans, this implies that no matter how high the cliff, how deadly the illness, or how inevitable the accident seems, there's always a sliver of probability where you make it through. And if consciousness navigates these probabilities, you'd never experience the timelines where you perish. You'd just keep waking up in the next universe over, oblivious to the versions of you that didn't make it. It's not that you're invincible, it's that your awareness is always eerily on the winning side of the quantum dice roll. Critics argue this is solipsism dressed up in physics jargon, a narcissistic fantasy that places individual consciousness at the center of reality. Yet the theory isn't entirely untestable. Quantum suicide thought experiments propose a gruesome but revealing scenario. Imagine a gun wired to a quantum trigger that has a 50% chance of firing each time you pull it. In most universes, you'd die immediately. but in a vanishingly small fraction of branches, the gun miraculously fails every single time. From your perspective, though, you'd only ever experience the bizarre sequence where the weapon repeatedly jams, leaving you standing there unharmed, questioning the laws of probability. Of course, no one's volunteering for this experiment, but the logic holds. If consciousness is quantum, then subjective experience might be biased toward survival in ways that defy classical statistics. The implications ripple far beyond personal mortality. If quantum immortality is real, it could explain phenomena like near-death experiences or past life memories, not as glimpses of an afterlife, but as bleed through from alternate timelines where death was narrowly avoided. Even déjà vu takes on a new light. What feels like a memory might actually be a fleeting overlap with a parallel self's lived experience. And if consciousness can navigate the multiverse, could we someday learn to steer it? Ancient esoteric traditions speak of walking between worlds, while modern psychonauts report shifting realities during deep meditation or psychedelic journeys. These might not be metaphors, but intuitions of a deeper quantum truth that the boundaries between lives and even deaths are far more permeable than we've been taught. The most unsettling question isn't whether quantum immortality is possible. It's what happens to the other versions of you, the ones who didn't make the cut. Are they simply erased like unfinished drafts, or do their experiences continue in some form, forever separated from your stream of awareness? This isn't just physics. It's a mirror held up to the nature of identity itself, forcing us to ask, are we singular beings or infinite constellations of possibility, each convinced we're the only real one? Whether you find this idea terrifying or exhilarating, one thing's certain: the multiverse might not just be a theory about parallel worlds. It could be the ultimate survival mechanism, a cosmic game of musical chairs where consciousness always, somehow, finds a seat. Humanity stands at the threshold of something extraordinary, not just a scientific revolution, but a seismic shift in the very nature of awareness itself. The quantum awakening isn't about discovering new particles or equations. It's the dawning realization that consciousness isn't a passive bystander in the universe. It's the architect, quietly shaping reality through every observation, intention, and collective belief. Picture 100,000 minds suddenly grasping that their thoughts might ripple through the quantum field, nudging probabilities, bending the arc of existence. What happens when that understanding goes mainstream? When entire cultures begin to wield attention like a tool, not just individually, but as a synchronized force? History offers glimpses of this potential. The Maharishi Effect, documented in the 1980s, showed that when large groups meditated together, crime rates in surrounding areas dropped, as if collective focus could imprint order onto chaos. Skeptics dismissed it as coincidence, but quantum mechanics provides a framework. If individual consciousness can bias random events in labs, why couldn't mass awareness tilt societal outcomes? Fast forward to today, where global crises, pandemics, climate disasters forge unprecedented levels of shared attention. Could this be priming humanity for a tipping point, where the sheer weight of unified consciousness begins rewriting the rules of engagement with reality? The mechanism might lie in resonance. Just as a choir's voices harmonize to fill a cathedral, synchronized human intention could amplify quantum effects across the fabric of spacetime. Studies on the Global Consciousness Project, a network of random number generators scattered worldwide, reveal anomalous spikes in coherence during events that captivate millions: sporting finals, royal weddings, even tragedies like 9/11. It's as if the collective emotional charge briefly warps the background hum of randomness, leaving fingerprints on the quantum canvas. These aren't just statistical quirks. They're breadcrumbs leading toward a startling possibility that human awareness in sufficient numbers doesn't just perceive reality, it pressures it to conform. Now imagine this awakening scaling exponentially. As quantum biology, consciousness studies, and non-local phenomena enter mainstream education, the old paradigm of separation mind here, matter there crumbles. Schools teach children to harness focused intention like a muscle. Hospitals integrate group meditation into treatment protocols, leveraging the placebo effect not as a fluke but as a quantifiable science. Cities design public spaces to amplify collective coherence, architecting environments where shared purpose literally bends outcomes. This isn't utopian fantasy. It's the logical endpoint of a species stumbling upon its own latent power to converse with the quantum substrate of existence. The most electrifying implication isn't just societal, it's evolutionary. If consciousness shapes reality, then a species aware of that fact becomes something new entirely. No longer passive subjects of physical laws, but active participants in their unfolding. Ancient texts spoke of enlightenment as seeing through the illusion of separation. Quantum physics might be the roadmap to that same destination, dressed in mathematical language. The boundary between spiritual awakening and scientific revolution blurs until it vanishes, and what emerges isn't just a new understanding of the universe, but a universe subtly remade by that very understanding. This awakening won't arrive with fireworks or fanfare. It's already humming in the background, in every unexplained synchronicity, every gut feeling that defies logic, every shared dream that feels too vivid to dismiss. The pieces have been scattered across cultures and centuries, mystics whispering of unity, physicists mapping entanglement, ordinary people brushing against the edges of something vast and alive. Now those pieces are aligning. The quantum revolution isn't coming, it's here, and it's not happening out there in the stars. It's unfolding in the quiet spaces between our thoughts, waiting for us to notice. The only question left is, what will we create when we finally dare to look? From the moment a particle decides whether to be a wave or a pinpoint depending on whether we're watching, to the eerie possibility that our awareness might outlast our biology, one truth emerges: reality is far stranger, far more alive than classical science ever dared to imagine. These 36 clues aren't just isolated curiosities. They're threads in a tapestry, weaving together a story where mind and matter aren't separate actors but partners in an ancient, intimate dance. The double-slit experiment taught us that observation changes what's observed. The quantum soul hypothesis suggests that observation might be what makes existence real in the first place. Whether you interpret these mysteries as proof of consciousness's primal role or simply as gaps in our current understanding, they force us to confront a humbling idea: the universe doesn't just exist. It responds. Consider the ripple effects of this realization. If consciousness truly plays a role in quantum mechanics, then disciplines once considered unrelated, neuroscience and particle physics, meditation and mathematics, suddenly belong to the same conversation. Philosophers have debated the nature of reality for millennia, but now we have labs full of tangled particles and delayed choice experiments whispering that the truth might lie somewhere between measurement and meaning. Spiritual traditions have long claimed that focused intention can heal or manifest, while quantum intentionality studies show mind influencing matter at the subatomic level. The line between ancient wisdom and cutting-edge science is blurring, and what's emerging is a new paradigm, one where the observer isn't just a witness but a co-creator. The implications for humanity's future are staggering. If collective attention can nudge quantum probabilities, what happens when millions or billions of minds align toward a shared vision? Global challenges like climate change or social inequality might not just be solved through policy and technology. but through a fundamental shift in how we perceive our agency in the cosmos. Imagine cities designed not just for efficiency, but to amplify coherent thought. Education systems that teach children to harness the quantum power of focused awareness. Medicine that treats the mind not as a passenger in the body, but as its architect. This isn't fantasy. It's the logical endpoint of taking these 36 clues seriously. A world where science and spirituality don't just coexist, but collaborate. Yet for all the grandeur of these possibilities, the most profound shift might be personal. Every time you pause to watch a sunset, debate a choice, or even wonder about your place in the universe, you're not just a brain processing data. You might be a quantum phenomenon in flesh and blood, a localized knot of consciousness tugging at the fabric of reality itself. The mysteries we've explored today don't just belong to physicists in lab coats. They're yours to wrestle with, to test in the quiet moments when intuition defies logic, or when a coincidence feels too precise to be chance. So where do we go from here? The answer lies in curiosity, not just consuming ideas, but engaging with them. Question the boundaries between mind and world. Notice when reality seems to whisper back. And above all, stay open to the possibility that the next great discovery might not come from a telescope or a particle collider, but from the unexplored depths of your own awareness. The quantum revolution isn't just happening in textbooks, it's alive in every moment you pay attention. What do you think? Could consciousness really be the missing piece in physics' biggest puzzles? Or are we reading too much into quantum weirdness? Drop your thoughts in the comments. Let's keep unraveling this mystery together. And if this journey through the quantum-looking glass left you questioning everything, hit like, subscribe, and share it with someone who loves a good cosmic rabbit hole. Until next time, keep observing. The universe, it seems, is watching